an overview. This is a good shot. So this is looking over the floor of what's going on at Kids Week. You can see lots of NASA people. With the career panel coming up in a little bit. Some ladies talking about their jobs in a whole bunch of different divisions. And lots of other cool stuff going on. Hello from Wales. Well, hello from New York.
Nice. We have people talking.
That's cool. San Antonio. Yeah, guys, where are you watching us from? How's it going? Got South Texas.
All right, the member stream should be coming up as well on the NASA Spaceflight channel, and then I've also turned it on the Intrepid Facebook and the Intrepid YouTube.
Awesome.
With those titles, so we should be good. Yeah. Surprise! Yeah. Hey, Chris Bergen, I didn't do a members post. We were making sure that everything worked, and then we had some things with some audio music that was playing that we had to sort here. But if we need to do a members post or something like that,
we're live on Intrepid.
It's working.
All right.
I'll be darned.
So welcome everyone. Are we live on all the channels?
We should be live on all the channels now.
I'll give you this back then.
Thank you for my phone.
So everyone, if you can hear our voices, welcome. We're doing a live stream here from Kids Week, and you're getting kind of an overview look of what's going on the floor here during one of our space days at the Intrepid Sea, Air and Space Museum. Do you want to head down on the floor and get some better lighting, and they can actually see the talking heads that are talking right now?
Let's go. Like literally, it's behind the scenes, y'all. You're going to be walking with us.
Scenes. You're walking downstairs right now.
While I try to figure out how to read the members-only stream chat on my phone.
All right, so let's do a little bit more of a
Thank you.
Of a formal welcome. Hi, everyone. So I'm Alicia Siegel. I'm the producer of public programs here at the Intrepid Sea, Air and Space Museum, joined by...
I'm tapping on my phone. Don't put me on camera yet.
All right, joined by the one and only DOS from NASA Spaceflight, who we love to partner with as well. So we are tuning in here from Kids Week, all right? This is our big annual big festival. It happens every year during the midwinter break for New York City schools. So parents are looking for something to do with their kids, and we provide. So we actually bring in people from across the country, lots of exciting partners to do fun, educational, hands-on activities and demonstrations for kids. The first 3 days are space days, so we have NASA coming in. As you can see, they came out in force this year. We got some Artemis, we got some HLS over there, and we do a lot of just really fun activities with them. Then the next 2 days we've got arts and culture, so we have authors coming in, we have performances. Blue Man Group actually is going to be here all week long, but they're actually going to be doing some fun things then too. And then we have nature safari days. Zoo animals come into the Intrepid, I kid you not. We have kangaroos and alligators and parakeets. Kind of a once-a-year thing for us, but very cool anyway. And then we round out with engineering stuff as well. So we're so excited to be able to be streaming from the floor to kind of get to know what's going on, meet some of the people behind all of these cool things, and just give you a little taste of what's happening at Kids Week.
I'm trying to make sure that I spelled everything in the overlay correctly and everything. So it looks like it's all fine. I mean, It's all working.
Looks like it's working on mine too.
Go.
Excellent.
I can read chat. You have that chat there. I'm going to be switching back and forth between chats. I'm reading the NSF chat right now.
And I'm reading the Intrepid one. So if you have any questions for us or for any of the people that we are highlighting today, just pop it in chat.
Find the chat.
Hopefully, the Facebook chat for Intrepid. Yeah. All right, cool.
Well, shall we mosey over to the NASA folks?
Yeah, I know that there's a lot of excitement about a ship, a SAR ship, and some HLS. So let's start there for all of our fans, shall we?
Cool. It is an active environment.
Very active.
When we walk around, there are kids and families, and there's demonstrations. I think that's a vacuum forming demonstration over there. But we are in very much an active environment.
So much fun at Kids Week, guys.
All right. Do you want to start talking to them first, and then?
Yeah, sure. So, let's start over here because we have an open space.
Just show the starship so people keep watching.
So I'm here with the Intrepid, and we are kind of just highlighting different things that are going on for our live streaming viewers today. Can you tell us a little bit about, so we are at the Gateway table. Tell us a little bit about Gateway and how you're involved with it.
So this is Gateway. Oh, thank you.
Have a microphone.
Sounds good. Hi, welcome everyone. My name is Christina Zayed. I am a communications strategist for the Gateway program. The Gateway is managed out of NASA's Johnson Space Center in Houston, Texas. It is a lunar orbiting outpost that will help facilitate transit to unexplored areas of the lunar surface. So we've got many different components that comprise the Gateway, and it's currently being built with international partners and commercial partners. So for international partners, we're partnering with with JAXA, the Japanese Aerospace Exploration Agency, the Canadian Space Agency, and the European Space Agency, as well as Maxar, who is building the power and propulsion element, so that will power the Gateway, and the habitation and logistics outpost, which is being built by Northrop Grumman. Those will launch on a co-manifested vehicle, a SpaceX Falcon Heavy, and we're targeting 2025 timeframe for that.
That's coming up.
Yeah, it's coming up. We're really excited. Lots going on. So
that's awesome. So partnerships and international cooperation is really the name of the game. It seems like
it's
a lot
very
of this
important.
stuff.
Yeah, and we're building off what we've learned with the International Space Station. So lots of lessons learned and tips that that we've taken from the International Space Station and applied that to the Gateway. Although the International Space Station is much larger than the Gateway. We're talking, the Gateway is only about a sixth the size of the International Space Station, but there are a lot of similarities. So you'll see here on the power propulsion element, we've got the rollout solar array, very similar to what was recently placed on the International Space Station, the IROSA. So lots of similarities and definitely taking what we've learned to build Gateway and to help in future missions.
So you say it's about a sixth of the ISS. So for anyone who is watching the Super Bowl this year, of course, they know the ISS is about the size of a football field.
Yeah.
We all know that now. So a sixth of a football field, that does seem kind of small, right?
Yes.
So how long are people, going to be kind of here as they kind of, use it to jump off to further places? What's the idea of how long people would be spending there and how many people at a time?
Yeah, so it's a 15-year lifetime or life cycle for the Gateway, and we're looking at up to about 30 days or so in orbit. So just kind of giving you a similarity, we're talking about the International Space Station. That has been, the International Space Station is 30 plus continuous years of, living on board on station. This won't be continuous like the International Space Station. We'll have missions that will kind of bring our Artemis astronauts in orbit throughout the year. So.
Very cool.
And then just kind of also giving a comparison. Well, we're giving comparisons. We'll throw one more out there. You said football field for the International Space Station. If you want to think about a size comparison for Gateway, we like to compare it to a nice one-bedroom condo. So that kind of puts it into perspective.
Now, is that a one-bedroom condo in New York City or a one-bedroom condo in
those are
Charlotte
small,
or something?
I gotta say, the ones here are kind of small. I would say just maybe more of an average-sized condo, not a New York.
Not a shoebox like in New York City.
No. Okay. Yeah, you guys threw me in for a surprise with those hotel rooms, I've got to say.
Oh, yeah.
Yeah.
Yep. We live like astronauts here, I guess.
Do.
Nice and tight.
It is. But we're looking forward to it. Yeah.
Any questions from the
we
crowd
didn't tell them they could ask questions.
Oh, gosh,
Tell them
yeah.
they could ask
Please,
questions.
if you have questions for any of our people, guys, ask away.
And then also, just while we're out here, you guys can follow us on Twitter. We've got QR codes here, but you guys are welcome to follow us on Twitter and Facebook. We're continuously posting news, milestones, and whatnot. We recently, this is our habitation and logistics outpost, so we recently brought in the mock-up for that in Building 9 of Johnson Space Center. So our Artemis astronauts will soon be training for future missions. So real-life kind of perspective of what to expect when they're on board living and working and conducting research.
Very cool. All right, well, thank you so much. This was great.
Yeah.
All right, so let's head on over.
Back.
Sorry about
Thank
that.
you.
So I
can talk again. I have a microphone.
These lovely ladies earlier.
Wait, I'm going to lose my microphone again.
This is something that our crowds are definitely going to be very interested in. This is the Human Landing System program. This is familiar to anyone. The shape, maybe? At home? I was joking earlier. It's essentially a very familiar shape, but with a NASA skin on it. We got the worm logo there on the side too. So, ladies, please tell us a little bit about what you do and what Human Landing System, HLS, is all about, and your partnership with SpaceX.
Absolutely. So we both work at NASA Marshall Space Flight Center, which runs the program office for the Human Landing System. So we partner very closely with SpaceX, who is our provider for the option A, which is the initial lunar landing demonstration. And so this is the mission that's going to take the first woman and the second person and the first person of color down to the lunar surface. So we haven't been back to the moon since the Apollo program, and so this is going to be a very exciting next step for us.
Okay, so tell us more about like the time.
I muted you. So.
Oh goodness, sorry, we're having technical issues. Tell us more about the timeline of all of this. When you think you're actually going to have prototypes going, anything like that?
Absolutely. So it sounds like y'all are closely tracking
We are.
the SpaceX development down at Boca
Definitely.
Chica. So last week we were very excited to watch their booster test. So Booster 7 just test fired 31 of their engines. It was a very successful test. So the next big milestone that we're looking forward to is the orbital flight test. And according to Twitter, we're all very much looking forward to seeing this next month. So once we have that, we will be ready to move into more of the HLS specific development, moving towards a uncrewed flight test, uncrewed landing on the moon in 2024, with the crewed Artemis 3 landing targeted for 2025.
When you watch the booster test, how do you watch it? Do you get like secret feeds? Did you get to go there in person, or how do you watch it?
I wish. So it's actually really funny. So we are in meetings with SpaceX all day long, and all of us have it pulled up on YouTube.
Yeah.
And we also
on your channel.
Yes.
And
It really is your channel.
so thank you. And
Nice.
we also have, we have insight into some of their systems where we can watch, through
Yep,
the
yep.
operational steps that they go. So we will be in a meeting, and literally somebody will say, okay, we're getting close. Everybody, let's pause it. Somebody will pull it up on Teams to screen share the YouTube
No
feed.
kidding.
No kidding. And we will all cheer, and we'll all say congratulations, and we'll move on with our meeting like nothing happened.
No kidding. You like pause your meetings to
We
watch
do.
the test on YouTube.
Yep.
That's awesome.
Fangirl out just like you guys do.
Excellent. There's some people asking, is there anything like about the interior yet? Is there something on here? Has anybody done any designs? How the astronauts will sit or anything?
Yes, so there's a lot of work being done on laying out the crew cabin. It is actually something that we're very involved in at NASA. So the crew office is in a lot of our meetings. We have folks from the crew compartment office, which is part of HLS, and they are very involved with like how are they laying out the controls, how are the crew quarters, how is the waste management system,
Yeah.
right? Big topic of conversation.
Lots of giggles.
So that is something that we have, been very, very involved in. They have mock-ups, I believe, in Hawthorne,
Yeah.
where the crew has gone out. They'll have office hours. They'll talk about all of it. So, it's really coming together. It's exciting.
Nice. I'm on my phone because I'm reading chat while we're doing this, right? I'm seeing if there's any questions. People mostly just saying thank you.
Awesome.
Everybody's super excited to see Starship with logos on it and to start seeing the interior.
The worm.
Yes.
It is so exciting to have the worm on there.
Was that like a big decision, or you just said nope, we'll put the worm on
It
it?
probably was. It was probably lots of
Back
closed
and
door
forth.
conversations at headquarters, but there it is.
Yeah.
All of us cheered for it.
Yep.
Nice.
It came back.
Good deal. Well, yes, everybody's now saying that worm is the best. Worm gang.
Yes,
This is how it
yes,
goes.
it's everywhere.
You have, yes, everybody.
I love it.
Something else actually that's interesting. So we have this kind of large stand up here, and I see there's 4 windows and 4 people on it. So the last time we went to the moon, it was Apollo. There were not 4 people crammed in that lunar lander. So this is now intentionally there will be more people, and will all 4 people be able to go out onto the moon? And
So for the first mission for Artemis 3, there are going to be 4 people that launch, but on Orion, there's only going to be 2 people that land onto the lunar surface. So for some of the sustaining missions, there may be more people that land, but right now it's just going to be 2, so they're going to have to draw straws.
oh, is that how they're going to do? Oh my God! can
It'll
you
be
imagine?
pre-planned. It'll definitely be
Oh
pre-planned.
man, I could see some problems with that. Of course, they'd have to be trained. What am I saying?
Yeah.
Cool.
Nice.
Any other questions?
It's just people saying thank you.
Oh,
Awesome!
No,
Well,
we
thank y'all
love
so
it.
much.
Yeah, thank you for
we're
being
very
here.
excited about this.
Yeah, everybody's so excited to see what's going on, and everybody wants to see like white painted stars, like all these things.
Yeah.
There's a lot of fans out
It's
there.
definitely very polished when you look at the ship 24. It looks a little bit different.
Which ship is this?
Serial number, I do not know.
Serial number, don't know.
Nice.
We'll allow it. Good deal.
We'll get there.
All right.
So, guys, if you are curious about what's going on with HLS, I was talking to them earlier. We definitely want to try to feature you on a Future Astro Live show at the museum. So, of course, that would be on one of the NSF Live slots coming up in the future in the next few months. So, thank you guys again so much for talking with us. Thank you for being here at Kids Week. We love hearing about all of this cool stuff. And let's keep roaming, shall we?
Cool.
All right, thank you so much.
Thank you guys so much.
Nice. Wait,
I'm gonna
wait.
hand this over to you.
Grab that one. Do I have to grab them all?
Yeah, I gotta.
Oh my gosh. Yeah, that's live. Yeah, like right now. Like
Oh, great.
we don't record it. We're just going live.
right,
Well,
so-
thank y'all.
Yeah, like nobody should edit that, right? No.
There's no edits. It's all just live.
So we've got moon habitats here, right? Is that correct?
That's the habitat.
Habitats. All right, so I'm going to hand it over to you.
Here's a microphone. Who would like to talk?
We're streaming live right now to our Intrepid pages and some members' pages. So tell us about what you're doing. I'm going to hand it over here.
All right, so I'll start.
Would you like to and sort of hold it up here? It's almost like a microphone with no stick.
Okay, so I'll just give, this is a quick picture if you can get that. That's our Artemis base camp. So that's a concept of what our lunar missions are going to look like. So if you look here, we've got the habitat. So the habitat's two parts. One part's inflatable, and so this is a model of the material for the inflatable habitat in its inflated position. And this is a similar material in its deflated position. So it'll launch, basically flatten, and when it lands on the surface, they'll inflate it. And this is kind of our 3D printed model of what the actual habitat volume would look like. So this is configurable. It could be crew quarters. It
Yep.
could be experiment stations. It could be a kitchen, a galley, gym, and it repeats itself down there. And this is the airlock, which is not going to be inflatable. It's going to be made out of this isogrid structure.
So you're actually starting. I mean, you've already got materials.
We've
that
got
you've
materials.
worked
They're
on.
already testing these materials at Marshall Space Flight Center in Huntsville,
Yep.
Alabama. They actually did a burst test for one of the companies a few weeks ago, so we're moving on that. Obviously, you've talked to the lander folks. They're going to help us get this cargo to the moon.
Yep.
Along with the astronauts, and you've talked to Orion and hopefully SLS.
We're going down the
this
line
is kind of the whole. This is where it all comes together, and this is what it comes together for.
Gotcha.
And we've got other systems besides just the habitat, right? Because we're going to actually build an outpost on the moon. So you need habitats, you need communications, you're going to need rovers to move around.
Yep.
You're going to need power. You're going to need some way to find your way around. So you're going to need like a lunar GPS. So all this is in work, and we'll roll it out in phases.
Gotcha. So it's not just like you've drawn the things up or somebody had some ideas. You're already moved into testing
design and
materials
testing is underway right now.
Excellent. I have to ask, like, it makes sense, the inflatable, expandable habitat, because you pack it down small, and we're sort of constrained when we talk
Right.
about rockets inside the payload fairing or whatever.
Right.
But how do you get it out of a rocket like that onto the ground? Or is it a different rocket that'll take it? Or
So it's going to go on one of the human landing systems.
one of the human landing
Right, yeah.
systems?
Yeah, it will not go on. So that'll deliver both crew and cargo to the moon. So they're working out how to offload cargo.
How to actually offload it. Gotcha. So you've got all sorts of concepts of how that will work, but, does this land itself and then it just inflates, or
Right.
does it come delivered by something else? That's
Right.
still sort of like being worked on, I guess.
Right, yeah. There's a lot of the architecture that we're still trying to refine.
Gotcha. I'm looking at my phone because I'm also reading viewer questions
Right.
while we're
Okay.
talking.
Oh, great.
I'm not like, oh, this is super boring. I'm just going to check Twitter. That's not what I'm doing. I'm looking at questions from the viewer. What are the plans for the vehicles, and are they going to be constructed? So you said we've got some other things like ways to get around.
So they're looking at both pressurized rovers, so they can leave the base camp for a while.
Yep.
And live on board and
Like
do
in The
some
Martian?
science.
I don't know if you can
I
say
have
that.
not seen The Martian,
What?
so I like The Martian.
How are you going to design anything?
I'll take your word
No,
for
I'm
it.
kidding.
And then unpressurized rovers, if you just want to go for a little, in distance where you can come back to the lander or base camp.
Right.
So as we build up more resources, we'll continue to add. It's going to gradually, like you're building a city. You start something small and it keeps getting bigger and bigger, and you end up with Manhattan.
Yep. Is it like in the concept stage, or are they starting to put together metal for a rover, or
I
where are
think
you
we're
at?
at the concept.
Gotcha.
We're requirements, formulation. What does a rover need to do? That's
right.
Before you build something, you have to figure out what it needs to do. So that's kind of where we are.
Right. And like you said, you're sort of building into it. Is the first mission that lands on the moon going to have all this cool stuff? Or is like
the first mission
one?
is what they explained to you over on the human landing side. We will land the astronauts. They will spend the amount of time that the mission takes on, and then they'll go back to Gateway, meet up with Orion, and then come home.
Yep, gotcha.
And then we'll just keep building on from there.
You like build it over time,
right?
But it's not. I mean, looking at the pictures, it's not the sort of thing where it's like, oh, we go, we jump off, we plant a flag, we did it. Bye.
No. This is a long-term presence on the moon. The other thing this picture tries to show you is how what we do on the moon is going to be extensible to Mars. So a lot of things we prove on the moon, because you can get there in 3 days, is going to help us when we get to Mars.
Gotcha. That makes sense. I also had to note, like, we've got the worm fans over here, the NASA worm logo, but everybody here seems this is like the meatball table. We're getting some West Side Story stuff. Like if y'all are snapping fingers over here all of a sudden, we're gonna have to look out. There'll be a thing. There's a whole standoff between the worm fans and the meatball fans. It's a meme. All of our viewers like to say whether they like the worm or the meatball. And as soon as I mention it, 100 people will be like, "We're a meatball," and start fighting about it. So we love all NASA logos equally. Just kidding. Worm's great. Anything else you want to tell us? You've got all sorts of cool materials here. You showed us the aluminum orthogrid. I almost said isogrid because something. I thought I just remembered wrong. It actually means something different.
You need to bring one of those too.
Nice. She said isogrid is the triangles, and orthogrid is. Does orthogrid mean rectangles?
That means orthogonal, so it means they're perpendicular to each other.
Oh, well, there you go. See,
so you end up with a rectangle.
That's why I don't design this stuff. I just talk about it on camera. Anything else you want to share, like the materials or anything? I love this because it's like things that are here. It's not just like a PowerPoint presentation or whatever.
Well, we tried to bring, we want as many people to come out and see what we got, and we're happy to talk to anybody who's...
All right. I'm going to scroll through chat real quick and see if there are any other questions. A lot of people asking about nuclear generators. I don't think we're quite there yet.
I don't know that we're not there.
There is a lot of power generation technologies that we're thinking about. And small nuclear fission reactors is one of them.
So lots of things on the table.
Lots of things on the table. No decisions have been made yet.
Gotcha. All right. Let's see here. I don't think you inflate the habitat with a tire pump like a bicycle. It's a little bit more involved.
How do we inflate it? That's Brooke. She's another one of our team. We're going to drag her in here.
If you walk over here, we're going to hand you a microphone.
Come on, Brooke. So how do we inflate this? Do we have tanks of pressurant that will then inflate the question is you don't use a bicycle pump to...
No, so yeah, we'll have tanks.
Have a mic.
No, it's fuzzy. We'll have tanks in there, and it'll just pressure. Or first, it'll blow up these, and then also pressurize the inside of the facility. It will inflate. It will inflate them, and then also pressurize the inside of it, and so that's how we're going to get the same structure from there that we would have here.
Gotcha.
Is that?
They can't hear me. I don't have a mic.
So, I'll hand you mine out.
There we go.
What's in charge?
Sure. It's a big thing. There was a difference with Bigelow has the beam, the expandable activity module on the space station, and I did a show with Bigelow, and they were very much no. You have to say expand. It's not inflated; it's expanded because it was a mechanical, like a piston system.
He's totally right. So when we go in the launch vehicle, this whole part is actually going to be the same diameter as that, and then once we get up there, this whole part's going to expand, and then that's how you get so much crew volume. So you got the little crew habitats down there. We're going to sleep. We'll have kitchens and exercise and laboratories, but then we'll still have this metallic structure in the middle, and that's where they'll get to go if there's a really big solar proton or radiation. They can go hide in there.
Makes sense.
And then that's also where they're going to go and put on their spacesuits so they can go walk and do, hit the rovers and keep the dust down in there because, the Martian dust or the lunar dust is very bad to electronics.
You can't get it out of anything.
It's so microscopic that you can't even see it. So the whole concept of clean till you see it clean.
Yep.
That doesn't work.
Doesn't even make sense.
So this is a big thing for us. So we've got to make sure we keep that down there so it doesn't interfere with anything.
Gotcha. Let's see here. They're getting ready to do the next presentation, so when the presentation's going, we sort of stop talking to people, I guess, is the right way to say it. Huh?
Can we still hear?
I think they can still hear, yeah. I don't know. We're making this up as we go, by the way. I don't know if you could tell.
So are we.
Yeah. If we were on the moon,
Can still hear.
I think we're fine.
Keep going.
Yeah. They need a foosball table in the habitat.
Oh, that's on the second.
That's on the second floor. It's just, it's not in the 3D printed model there. Sorry,
Yeah.
the foosball table is not represented. Let me see if there's any other questions. Oh, well, you were already talking about that. Somebody was asking what the plans for handling the regolith are and decontaminating things so you're not dragging moon dust into your habitat.
So, yes, that's actually probably our biggest risk besides the radiation that we have going on right now.
Yeah.
It is, like I said, because it is so microscopic. So we're actually building laboratories right now to teach us on, like, put something in there, put the regolith in there. How does it react? How do we keep it clean?
Right.
And we're working that actively right now because it is a very big deal. You don't want it to get into your electronics or your echoless system, where you're going to breathe and that kind of stuff. So.
Plus, it's sharp, too, isn't it? Because there's no erosion, there's no water to sort of wear it down. Like, nice, you wiggle your toes in the sand at the moon, well, I don't know if it'll actually cut you. I haven't wiggled my toes in lunar regolith. But it's sharp.
It is very sharp. Yeah, it's very different. So that's another good part is, everyone thinks, well, yeah, dust is bad. We don't want to get things. But it is. It's very ragged and sharp. And so it can actually do more damage than you would think of just having dust floating around.
Yeah. And now people are giving you ideas like, are you looking at electrostatic filtering so you could use...
We are actually. That's good. I'm trying to remember some of the other testing that we've been looking at. But yes, we have been looking at electrostatic, just even, materials that would capture it. So we've got a lot of very smart engineers working on that.
Special ways to, like, shake your spacesuit whenever you go through the airlock so you get all the dust off. I mean, wouldn't it be great if you walked in and then your spacesuit got a static charge and all the dust just went off of you because of, like, that would be a really cool system. I don't know if it'll actually work. I made that up. I've seen it for camera lenses.
They're coming up with ideas like
they
that.
go through like a car wash,
car
just,
wash.
like power blast you somehow.
I've seen them do it with like ultrasonics as well, where you can sort of mitigate dust with vibrations or sound waves, and that's a way to clear camera lenses off. I saw a thing out at the SwampWorks at KSC, and they were cleaning camera lenses using like sonics to shake it off so it wouldn't.
Oh, there you go.
Maybe I wasn't supposed to tell the Marshall people about the stuff from the KSC SwampWorks. Sorry, SwampWorks. No, but so many cool ideas. It's one of the things. It's not just the rocket that gets you there. Oh, launch day, it's so exciting. It's all of the other systems. It's the materials, the designs, everything you have to do. It's not just about the launch day that gets you there. It's all the work you have to do in the background.
Did you already talk about planting potatoes?
Potatoes.
Did you already talk about that? Just kidding. I'm kidding.
No potatoes?
Martian, Matt
Well, on the space station, we do have a lot of experiments, called Veggie something.
Lab.
Veggie Lab. So that is very cool. And the thing I heard is actually the astronauts get super excited because they want to eat those fresh veggies. So they have to tell the astronaut, you're only allowed to eat 4 of those tomatoes because we got to bring them back down and look at them. But yeah, so we are doing all those experiments, which is a great platform for ISS to help us get to the moon. And then once we're at the moon, the platform to get us to Mars.
Nice. It's like they've eaten their piece of lettuce or their chili pepper. Or sometimes they grow flowers. I don't think they eat the flowers. But
it's probably better than those little MREs.
Microgreens. That's actually what they're really looking into now. And also, they were saying that strawberries, too, it's really hard to grow from seeds, but they're finding out ways to do it, which is fascinating.
Oh, my God. That'd be so amazing to have a strawberry when you've been up there for 6 months.
Yeah.
Anyways, I think we're going to have to step away here. Thank y'all so much for the time. Our camera battery's about to die, actually. This is how we do our broadcast. It's like, by the way, we need to switch our camera battery out real quick. Again, the folks from Marshall Space Flight Center working on HLS designs, models, plans, all that sort of thing. Thank y'all so much for the time.
Thank you.
And habitation. Thank you.
Yes.
Yes.
Gotta live somewhere.
All right.
Dad, you're right.
Then we'll just awkwardly take the mic away and then we'll walk away. So.
Nothing to see here.
Yeah, thank y'all. Anyways,
We have to switch out a camera battery.
how silly do we look like carrying these around?
Talking into triples.
They make little sticks for them so you can hold a stick like
I
an
think
actual.
that would look even weirder though. I
Just
don't know,
like-
like a lollipop.
The lollipop back and forth.
Fuzzy lollipop. I dropped it on the floor and it got fuzzy.
Where else are we going to go talk to people? Elisa knows.
We can head over to the other side.
Okay.
I mean, we want to talk to Planetary Missions. They've got a cool little AR/VR thing going on. We can talk to them about what they're up to.
We could.
Right.
How are we with the? I don't want to go over there making a bunch of noise too close to the stage. Is that okay? Like literally planning this on
Let's
the
go
fly.
on the other side.
Like far
So that
away?
yeah.
All right.
We're gonna do a little walk
We
while
have
that's
to fix.
happening.
We have to switch the battery real quick. We're not exactly sure how smoothly this will go. So
Hold your breath.
is
Hang
the
in
battery
there.
clear? Like, can you switch it out? It looks like it.
The fun
All
of
right.
live streaming, y'all.
Stand by. We're going to switch the camera battery, and everything may explode.
Well, hopefully not. How does this work?
I'd have to run up there to do it. So
Gonna do some B-roll while we're
yeah,
while we're
just
doing
turn the
this.
camera off.
Oh,
Here, yeah, just gracefully turn it off.
going good so far?
Yep.
Thank you.
Trajectory to get into orbit, and it was just a really incredible experience. I got to pull my team. They already go for our burn to get into lunar orbit, so just a real highlight of my career. And I think I'll get to do it again too on Artemis 2 coming up. I'll be a really
Sort of stuff, or
Yeah, I'm the robotics camera operator for this festival. It's not nearly as exciting as
a little bit about my journey. I mentioned that.
oh, it looks like we're live again. Hey, hey. 5x5? Can you all hear us?
Yes. Yeah, I just had to click a button on the laptop.
Super.
We didn't book a remote operator like Michael or Patrick or anybody today, so.
Next time. All right.
All right, lead the way. Let's go see
So
who
we're
we're
back.
going to talk
Let's
to
head
next.
over here.
How's it going?
So let's head on over to the James Webb people.
James Webb. We know some James Webb people. Thanks for bearing with us as well, y'all. We're like super low maintenance. This is why we're like a member stream sort of thing. I'm putting on my Twitch channel as well, but thanks for bearing with us as we run around with like 3 people doing the live stream. She is... I don't think that this thing actually tells me when I'm muted or not.
Yeah,
I'm not muted right now, right? There's no visual indication on this thing whether or not it's muted, so chat can just scream at us. Are you unmuted?
I don't know. Am I muted?
I don't know. There's always 2 lights. Anyways, whatever.
All right,
are we good?
Mike, can we borrow you for a little bit? So, there you go. So we are live streaming right now.
Okay.
We're live across the interwebs, and we just wanted to kind of highlight all of the different people that are here and what they're doing. And I know you in particular are someone that knows quite a bit about the James Webb Space Telescope. This is Mike Menzel. I got it right this time.
You said it right,
Menzel.
yeah,
I got it right
okay.
this time. Not to be confused with Adina Menzel or Adele Dazeem. Not related.
Although I fake being her uncle to get in restaurants every now and then.
It works, right?
Yeah, why not?
So can you tell us a bit about what's going on with James Webb? Obviously, you know, we were all glued to it being launched on Christmas Day a couple years ago. Very exciting. And now, of course, the first returns have come back. Those amazing images that we all were tuning in for over the summer, last summer. So what's up with Webb now? What's going on?
Webb started its mission, and it's a 5-year mission just like Star Trek, but it should go much longer than that. At least we hope it will. The science is going great. The telescope is working about 2 times better than it's supposed to.
Wow.
It's really, it's working incredibly. The images that we've seen have been spectacular. In fact, when the press first came out with that image, I remember my wife first saw it, and she said, "Oh, it looks like Hubble." And the truth is, it did look like Hubble. But what Hubble took 14 days to do, James Webb did in 12 hours.
Wow.
So we haven't even cranked this sucker up to 11 yet, and we're going to. You know, when I first saw that first image, I was on the team for about 25 years, and we designed it to see the first light that turned on in the universe. And when I saw that very first image, I was with a bunch of astronomers, and I was almost giggling. And I turned to them when I said, "Hey, this thing is going to, whatever's out there, we're going to see it." Right now, the scientists are well into their cycle 1 science. They have 1 year to publish their data. We get bits and pieces as they do the analysis, and the results are incredible. I mean, I'm already hearing the scientists walk around the hall talking about the things that they found that are completely unexpected so far. So,
Can you tell us more about those?
well, I think I'll let the scientists tell them.
Okay.
But we're supposed to see the first galaxies that turned on in the universe. I don't think we've seen them yet, but the stuff that we've seen, which is probably, came to be only about 300 million years after the Big Bang, which to cosmic history is very, very short, are holding some surprises. And I'm not going to scoop the scientists because they get very mad at me for that. But I think it's really, what we're finding is incredible.
So exciting.
I guess I'm reading my phone not because this is boring, but because people watching are asking questions.
Okay.
So I've got a couple questions real quick. Can you ask them, please, about the new discovery of the very small asteroid at the MIRI instrument? Is that something you can talk about?
No, I can't because I'm just not up to speed on it yet. So
there you go.
I give my apologies on that.
There's a lot of people who are very excited for James Webb things,
yep.
so I don't know what's good or
I'm
not.
excited. I'm wearing my James Webb earrings, guys.
And I complimented her on that. I go, it's very fashionable.
Oh, so here, what are you most excited about to target with James Webb to look at? Like you personally, do you have a favorite?
Personally, I have three favorites, and we built it to see the very first galaxies that turned on in the universe. And as I just said, I'm confident that we achieved our job. That it's going to, whatever's out there, we're going to see it. The second thing is, I really am interested in finding biomarkers or evidence of biomarkers on exoplanets. Those are the two big ones. The third one is, to guys like me, rather obvious, and that is, I hope we find something that has been completely unanticipated. That it'll open up a whole new field of research that we just didn't even know how to ask the question.
Yep.
And if James Webb is true to its predecessors, that's very, very likely to happen. And I'm looking forward to that.
Like you don't know what you don't know.
You don't know what you don't know. And I think that within the cycle 1 science ends at the first year, then people start publishing. And maybe by this time next year, if you interview me, I won't scoop the scientists, and I'll be able to talk about the great things that they found.
So we'll ask you again next year, Kate.
I hope
There you
so.
go.
How about that?
How can James Webb help improve our discovery and investigation of exoplanets? So you said biomarkers. What can James Webb do to help us determine what a biomarker or see a biomarker?
The performance of James Webb is so good that when these planets, exoplanets, go in front of their star, they get an eclipse. But if you look at the depth of the eclipse in different colors, you can start to determine maybe what that atmosphere is made of. For instance, if the atmosphere has water in it, as I can show you in the camera, water is very opaque. So if you look at the colors of water, the eclipse would be deeper in that than at other colors. So you could find water, carbon dioxide, carbon monoxide, methane. And if you find these things in the right combinations, that indicates life.
Makes sense. Just like looking through the spectrum or something. Is that the right way to say it? Like looking at the spectrum that shines through a planet's atmosphere.
And by the way, that's exactly what it is.
I thought I was making it up. But
No. I didn't want to say we could get the spectral signatures, but that's exactly what we're doing.
No kidding.
We got some too, right? With
We
the
did.
images.
Oh, I'll show you that in a little bit, yeah.
In a little bit. Oh, you're going to do a stage presentation, aren't you?
Right.
That's right. Let's see here. Has James Webb been pointed at an exoplanet yet to do any of these observations?
Yes. Matter of fact, one of the first things James Webb did, and this came as a surprise to me, by the way, it looked at an exoplanet that we knew of, that we knew had water on it, and James Webb not only saw the water, but because of the shape of the spectral features, because of the shape of the dips, we know that the water is in clouds. And now Webb was the first one. I think Webb was the first one to detect water clouds.
No, so just it changes based on if it's higher in the atmosphere, or
no, it's the shape, and this is a little out of my field, but it's the shape of the dip, the shape of the spectrum that indicates. And we found clouds.
Gotcha. That's cool. What else? What else do you want to tell us about James Webb that we might not know yet?
Well,
what sort of question is that?
I'll talk about the engineering on it. I'm going to let the scientists talk about the science of it. But we're all proud that Webb is working as well as it is working, because the Ariane 5 put us on such a perfect launch. We have over 20 years of fuel. Wow. And we're all, I'm still working on the job. We're all working hard to make sure it's going to last as long as it possibly can. And on the side, myself and some of my colleagues, we're starting to think about the next one.
The next one?
I like it.
Ooh.
I like it.
So with Hubble, obviously, we had servicing missions, and actually Mike Massimino, a large part of that, who works here with us at Intrepid. So is there any thought of servicing Hubble? Not Hubble, servicing Webb, or is it just you're going to move on to the next one?
Webb really doesn't amend itself to being service.
Right, like where it is. It's a lot further away.
It's not only where it is, because the next one we're going to put out there as well, but the next one we're going to make serviceable.
Okay.
It has to do it because it's infrared. There's a lot of thermal blankets that have to tighten it up, and it wouldn't be. It's not the instruments aren't very accessible, and it would be hard to service something like that.
Gotcha. Just the way it's put together, and the fact that it's so sensitive with the heat shields and the instruments that have to be cooled down in order to operate correctly. You just don't want anybody messing with it.
But we did put targets on it so that if robotic servicing matures quicker, we could grab it. And there are, for instance, we could refuel it. But very early on in the mission, I was telling people who were asking me about refueling, and I said, well, yeah, but don't worry about fuel, because I knew we had over 20 years on board. So.
Gotcha. What about the meteorite, the micrometeorite strikes? Can we ask about that? Like,
yes,
was that
I'm
surprising?
Glad you did. Well, look, we designed Webb to withstand micrometeoroids, so we had to guess what the micrometeoroid environment was like. It turns out our calculations were pretty good. We were getting hit maybe 2 times a month by micrometeoroids of very, very low energy. We've had 28 strikes so far, which is about what we expected.
Okay.
They're all hardly measurable, except for one. That one was probably an energetic fluke. It can happen. And even after that one, we are still working twice as good as we're supposed to. So,
no kidding.
I mean, you can never know what happens in space, right?
Yeah.
But so far, micrometeoroids are actually behaving, with the exception of one,
With the one.
what we expect, as we expected.
I mean, you can't see them coming is the thing. It's like a statistical sort of thing.
That's correct.
That you expect you're going to encounter this many of them, but it's not like they the radar shows a micrometeorite approaching. Dodge, James Webb. Like, that's not how it works.
No, they're, on the average, they're going about 30 kilometers per second. So,
Yep.
And by the way, I've heard people describe them as grains of sand.
Yep.
No, they're dust particles. They have it's about a milligram is the average size of them. Yeah, but a milligram going 30 kilometers per second.
Still a lot of energy.
There's a good amount of energy, but these are not grains of sand. They're literally dust particles.
Gotcha. And it's almost like you know how it feels when you're driving down the road and you get a ding on your windshield? I don't know if anybody knows what that's like, but you don't see it coming. You can't predict it or dodge around the little dust. It's not even a dust particle. It's a rock if it hits your windshield, right? But that's sort of how it is. You don't know that it's going to happen until it happens.
That's
This
correct.
30 kilometer per second piece of dust hitting your mirror.
Right.
Like, what are you going to do? It's just you build it into the system, right?
And we built it. We predicted, or we had to estimate what kind of dust we'd be hit with.
Yep.
And with the exception of that one, our predicts look pretty good.
Nice.
Which means, as long as we don't get hit by, more of these energetic ones, micrometeoroids are not going to be our problem.
Gotcha. What? How do you test that on the ground?
We can't.
You can't. You can't get a piece of dust going 30 kilometers per second?
I think the highest velocity we can get on the ground, and we did test them, by the way.
Yeah.
I think it's more along 5 or 7.
No kidding.
Yeah, so...
That's tough.
That's
just
tough.
send it out there and see how it's going to perform. But it's still performing way better than expected.
Yeah, and by the way, people need to understand something else too. I've had questions about is the L2 environment, more dangerous than Earth?
Right. Does stuff collect there?
The
Is
answer,
it more
no, the
clear,
answer
or?
is just the opposite. Low Earth is more dangerous than the L2 environment because we had man-made stuff floating around up there. And let's just be real about something. We've been putting astronauts in spacewalks, EVAs out there for 50 years. It's a dangerous environment, but we've calculated the risk, and the risks are pretty, history has shown the risk is there, so, you don't want to poo-poo that, but we've lived with the risk for 50, 60 years.
No kidding. And we haven't parked a lot of spacecraft at L2, and we haven't had a lot of spacecraft break up at L2, right?
That's correct.
We've got lots of stuff in low Earth orbit that's
nice
just
and
falling
clean.
apart.
It's nice and clean, and to boot, L2 is what we call a metastable point. The stuff that's out there won't stay there for more than 6 months. Every 6 weeks or so, we fire thrusters to keep stay in orbit. Right.
Gotcha. It's not like like the sidewalk, there's the place where all the leaves gather in the corner or something like that. It's not like that. It's more like a hill where things fall off the top of it.
Meanwhile, Earth is like the divot that you're talking about.
Yeah, it's like the
Earth's gravity
sewer,
holds
the gutter
things.
that holds all the junk that we've sent up there, right? Versus
right.
L2. I'd never thought about it that way, but that makes sense. I'm going to reach out, so I'm going to look at y'all's questions one more time and see if there's anything else. L2 is L2 is a depository for spaceflight images. Thank you. The NASA spaceflight members area is called L2, and so there's some L2 jokes in chat.
My apologies to L2.
My apologies to L2. Nice. Deflectors, you're not going to put deflectors in front of the mirrors or anything like that.
No, actually, for the next telescope, we're seriously putting a barrel.
Right.
But for an infrared telescope, you could not. See, we got to make our telescope cold,
right,
so it doesn't glow brighter than the stars we're looking at.
Right.
A tube around it would have trapped the heat.
Traps the heat.
It wouldn't have allowed us to get cold. So, but for the next telescope, that would not. It's probably not going to be cryogenic.
Gotcha.
We are thinking of putting a tube around that one.
Let's see here. I never thought of it. Hubble has the tube. Hubble has a big structure, but James Webb is just flat mirrors exposed to space. I say just. Yeah, it's just flat mirrors exposed to space. No big deal, right? Let's see here. Oh, have you learned any lessons in the time that James Webb's been in space that inform your design for the next telescope?
The answer is yeah. And by the way, the barrel is one of them.
Yep.
Because whereas the micrometeoroids are not hurting James Webb.
Right.
Period. But if you're going to put a telescope that's going to be looking in the visible, out there. We would probably, those micrometeoroids might have more of an impact. So we're thinking for the next telescope that might look back in the visible.
Right.
We'll put the tube up there. We have some other lessons learned, but the truth is the lessons learned that we got so far are pretty technical, and they're almost kind of, I don't want to say arcane, but
sure,
would take too long to really talk about. But
gotcha. Let's see here. What's next? Using James Webb for another 18 years or something. That's what's next.
Well, that's what's next. But a lot of us, and I'm not speaking on the part of NASA, this is Mike Menzel now, but, we know how to build a big telescope and get it out there.
Yep.
I would like to evolve the architecture that we currently have and build a bigger one.
Okay.
I'd like to build something around 9 meters, but
kidding.
We'll see.
We just need some larger lifters to carry those, or
the larger lifters are coming.
Yep.
And I'd like to leverage them.
No kidding. It's got to be an interesting feeling because you're always so space and mass and everything constrained, and then all of a sudden something super huge comes along that can throw a telescope up that's, I don't know, 10 times bigger. I made that number up, but a lot bigger.
A lot bigger.
You're less constrained about the exact mass.
And don't make no mistake, when they make a bigger telescope,
when
they make a bigger launcher, us engineers will fill it.
You'll fill the space.
Yeah, we'll fill it.
The mass and the volume constraints,
you'll
fill it.
Right.
That's going to be a thing to see. Mike, thank you so much for the time.
Thank you.
I appreciate you talking with us here. Again, we're just doing this live, sharing what's going on here at Kids Weeks. We'll let you get back to talking to the kids. And oh wait, why'd the thermal camera go off? I'm sad.
I don't know, but I got to get ready for my talk anyway. So hey, thank you,
Mike. Thank you so much. Don't steal my microphone.
I won't.
All right, y'all say thanks. Thanks a lot. Anyways, y'all, Elisa left me. I don't know where we're supposed to go next. She was the one who went around in advance, and I guess I can talk into two of these at the same time. She is introducing the next talk, and then she's going to come around and talk to us about where we're going next. How's it going so far? I know this is totally off the cuff. We're walking around with a little lavs. I hope I'm not echoing or anything for you right now. I don't think I am. But give me some feedback while I'm reading real quick. Look at this. Hang on a second. You think it beeps? Do I need to put a lav on it so you can hear it beep? It's like, I want to look around for the person with the controller. Or do you think somebody maybe rides in it? Anyways, that's Kids Week. There you go. I'm going to read some chats here. Yes, beep boop. Beep boop or whatever the other. I can't make very good R2D2 noises. Interview the droid. We'll go put the lav on the droid and be like, excuse me. Ask if he wants to be a camera bot at Starbase. Does he count as a drone? Like if he fires up the little thrusters in the prequels or whatever, does that count as a drone? Loving the stream. Excellent. Thank you, Austin. Stream's great. Thanks for making it. Cool, Benjamin. Let's see. I wish I was a kid here. Yvette says, we've done quite a few of these in the past. Like before I worked with NSF, we would come out here. The Kerbal Space Academy and my Twitch stream would come out, and sometimes we would have a booth. We would walk around and talk to people like this. It's something that we haven't had the opportunity to do for the last couple years. So when Intrepid said, hey, doing Kids Week again, can you come help us share it on the live stream? We said, sure. We wanted to come out and help them share what's going on here at the museum. So it's a lot of fun to get to walk around. There's so many different NASA groups and stuff. I don't even know all the NASA groups that are here. I just read the banners and stuff. But let me see if we missed anything. Your R2-D2 rocket caught fire in the second flight.
What?
We were trying to interview the droid that went by and ask it if it wanted
Was it the droid you were looking for?
I mean, I'll look for whichever droid. Like, it doesn't matter. I'm low maintenance when it comes to droid.
Which one?
R2 drove by.
Oh.
We wanted to ask it if it could go to Starbase and be a camera bot for it.
And? What did it say? Isn't that your job?
Yeah, just,
to hook up the robots?
Droid,
to feed the droid army? Cupcakes?
Like, hijack the R2. And, what's next?
That's
what
hilarious.
do we have coming on next?
All right, so we just talked to Mike from James Webb. He's going to be giving a presentation shortly. Let's go around the corner here. So the reason we did it in this order was actually because some of the people we're about to talk to were just on stage. So let's go this way.
All right.
All right.
Hey,
Hi, guys. So we are live streaming right now from the floor, just highlighting some of the cool things that you have out here. Tell us a little bit about what is going on right now.
And I'm going to hand you a microphone, too.
Sure.
There you go.
I'm going to stand over here.
So we're here from NASA's Exploration and In-Space Services Projects Division, shortened just to Nexus. We're developing the OSAM-1 mission, which is On-Orbit Servicing, Assembly, and Manufacturing 1. It's going to do 3 big technology demos. The first, it's going to refuel a satellite that wasn't meant to be serviced. That's Landsat 7 right there. It launched in 1999. Right now it's running out of fuel, so we're going to put new fuel in it. Essentially what we're doing is we're rendezvousing with the bottom. There's a Marmon ring on there. We're grasping onto that, pulling the satellite into us, cutting open its thermal blanket, exposing the fuel lines, popping new fuel in it, that's hydrazine, and then sending it on its way. After that, we're going to do an assembly demonstration where we're going to take hexagonal components stored on the spacecraft and manufacture an antenna. And then the third demo is a manufacturing demo, and that's essentially 3D printing. We're making a 10-meter-long pole in space. After that, mission's done. Demonstrated all 3 of the major parts of ISAM, which is In-Space Servicing, Assembly, and Manufacturing, lots of acronyms, which is a big priority for the U.S. The White House has released its national strategy and implementation plans. The implementation plan was actually just released this December, so exciting time for the discipline.
You just said so much stuff. I'm blown away by how much is going on here. But so, in-space servicing, assembly, and manufacturing. ISAM?
Yes, ISAM.
Because NASA loves their acronyms.
We do.
So this really is the future. We are really going to need this in order to explore further, right?
Oh, yeah. We talk about something called the space superhighway, which is this infrastructure that we're going to need if we're going to make spaceflight more green, more sustainable, really extend into the future. So things like space tugs, they need robotic arms. Things like active debris removal, which is essentially smacking space junk out of orbit. All these things are real services that we're going to need within this discipline in order to make sure that spaceflight stays relevant and important.
That's something we all want, for sure. So, you're leveraging industry. Is there a lot of partnerships involved then, I think?
Oh, yeah. So the government is uniquely suited to do things like long-term technology development, and then we transfer those technologies off to U.S. commercial industry. Right now, we're doing the servicing mission, but ultimately, NASA doesn't want to be AAA in space. We want a commercial company to take over and make sure that there's a robust suite of services we can offer NASA, Department of Defense, and commercial organizations, too, that have satellites.
Yeah.
I'm reading questions.
You're reading questions?
I'm still looking for questions.
We're on our phones because
oh
we
my
have
gosh,
questions
please, no.
from our viewers here. That's amazing. Okay. So, in-orbit assembly then also. Mm-hmm. So, we saw that with the ISS, right? They
yes.
were able to assemble in orbit. Is this something that's going to be, going on with, Gateway and moving on to other, potential things with Mars or anything like that? I feel like, there's been talk of 3D printing and all of that. What is kind of the future looking like for that?
Sure. So assembly is huge for us. Obviously, Gateway is a good example. International Space Station is a good example. But there have been proposed observatories that have been assembled concepts. Essentially, we're overcoming the limitations of a rocket fairing. A rocket fairing can only fit so much. If we can launch things in multiple parts and put them together, we can make these big structures that were previously relegated to science fiction.
Yeah. Science fiction is where we get a lot of the ideas.
Oh, yeah.
Right? Either that or our brains, because we were just
ecosystem.
giving ideas to the Habitats people
That's
about
what we
how to
do.
shake off the regular.
Actually, we walk around to the NASA folks, and then people on the internet tell you how to do your jobs.
Oh,
Yeah.
love that.
We do it for you. We'll send you the
I mean,
invoice
give you
later.
ideas.
Yeah,
we try to give you ideas on what you could do.
But it's true, science fiction. It's where a lot of these things come from.
I'm still looking for questions here right now, so...
Right, can you tell us
a lot is
about
happening.
this?
About this? Sure.
Yes, shiny things.
So this is all the tools we've developed for the OSAM-1 mission.
Great.
Our division actually has its origins in the Hubble servicing mission, so many of these are based off the tools we developed for the astronauts. Essentially, these are all the tools we'll need to accomplish the servicing mission. Essentially, we're cutting into this, the MLI, multi-layer insulation, exposing the fuel lines. Down here, though, we're showing if you just switch the paradigm from this to a cooperative valve, suddenly you only need 2 tools. It's much easier, much simpler, and that's what we're hoping to move forward to in the future. However, NASA's not trying to establish these standards. We're working with commercial industry and the Department of Defense, and hopefully we'll unify together to something that everyone agrees on and wants to work with in the future.
Yeah.
It's like you need USB for the spacecraft.
Exactly.
Like some sort of standard.
A standard interface. Yeah.
Yeah. But that was the two different things. Like you've termed it so nicely here. It's like legacy, the stuff that's out there right now, and then cooperative means like I guess designed to be interactive, interchangeable,
and the discipline is so changing. We actually don't really even use the word cooperative anymore
Right.
because the opposite of cooperative is uncooperative. And it's not that these are uncooperative satellites.
I was going to say it's legacy.
Yeah,
and
they're legacy.
cooperative.
We call them prepared and unprepared now.
It could be uncooperative. I'm pretty sure Mike Massimino had an uncooperative tool and just broke something off the Hubble, didn't he? Yeah. That's his time to fame now, right? He broke the Hubble thing to fix the Hubble thing.
Let's see. So I'm hoping that the questions are in the right order here. But how much have Dexter's RRM test on the ISS helped your future goals? Dexter, RRM?
Oh, yeah, absolutely.
Yeah.
So
Okay.
RRM was big for us. RM3 is actually still on space station. We're working on decommissioning now. But yeah, we proved a lot of the core technologies that we're going to be using for OSAM-1. We also have a couple other payloads on space station. Raven, which at the time it was launched, Game of Thrones was very popular, so the three-eyed Raven. So that's
Raven.
the 3 cameras, which is visible, infrared, and LiDAR. And that helped us with a lot of our research to do the rendezvous and proximity operations for OSAM-1. We also have some astronaut tools up there. REL, which is it sort of sniffs for ammonia outside the space station, which is obviously useful because you want to save that EVA time. But yeah, Dexter's been a huge role. For this mission, we have robotic servicing arms. They actually look like this, but much larger. And there are 2 of them on the top of the spacecraft, and they're doing the servicing component. There's also what's called the Space Infrastructure Dexterous Robot, or SPIDER, developed by our partners at Maxar, and that's doing the assembly and manufacturing demos.
And I know Canadarm3 actually was just kind of recently announced too. Are you guys doing anything in cooperation with that?
Maybe, but not in my sphere.
Got it. No, I asked because actually, shameless plug here, in March, our Astro Live program is going to be about robotic arms. So we're going to be talking with someone from the Canadian Space Agency who controls Canadarm2, as well as someone who worked on the European robotic arm up there also. But, you know, there's so many cool bits of robotics and arms and spiders and things.
And Canada's
that are going
incredible
on up
work with
there.
robotics, yeah.
Shout out to Canada if anyone from Canada is watching us right now. So yeah, it definitely seems like less is more here. This is less stuff you got to take up, a less fuel you're going to need to get it up there. It makes a lot of sense to have, as you're saying, kind of a standard USB, port thing for that.
So questions.
Yeah.
How do you picture this working? Is it going to be people who want to launch satellites? If you use a specific type of adapter, then this satellite can help you out. Is this just ideas on how satellites can be serviced, or is this like, if you follow these rules, then you can be eligible for this satellite, AAA or whatever? Like,
I think the exciting thing about the discipline right now is that a lot of these things are still up in the air.
Right.
Things like parts of Roman could be serviceable. But we know in the future we just announced Habitable Worlds Observatory. We know that will be serviceable, so a lot of the lessons we learn when we make that serviceable are going to be sort of what defines the future, I think. But I certainly can't speak to to what the future holds.
it's just ideas, because it's always been that we build a satellite and we launch it and it goes and it does its thing, and then when it's dead, it's dead.
Yeah.
There's no real refueling or real servicing. Like, we've done a couple little things here and there, but it's not the norm. And part
Right.
of it is, by the time the satellite is out of service, it might be obsolete with the way the technology goes, right? So why is it important for us to service satellites as opposed to just, let's just toss some more up there?
I mean, it saves you a lot of money in the long run. It's also greener, more efficient. Just by making a spacecraft modular, you can slot in and out components, and then suddenly you have a brand new observatory for the cost of just launching a little part, Same with Hubble. When we upgraded it with the last 2 servicing missions, we really changed the capabilities of the spacecraft.
Yeah.
And really allowed it to do the research it's been doing since then to today, which is kind of cool.
I think it's probably important also, electronics technology tends to advance very quickly, but things like valves and tanks and that sorts of things, it maybe doesn't advance on the same level of electronics. So while the electronics maybe leapfrog pretty quickly, if you're just talking about refilling a tank and then putting in a new processor or something, like those are 2 different things, right?
Oh, totally, yeah.
Yeah. Again, folks, I'm just going through chat here trying to see if there are any other questions. And some of the questions I have no clue what they're asking. So I'm like, I don't know.
Rephrase your question.
How does the printing and assembly compare to what orbital assembly is doing?
Oh.
I don't even know what that means.
Orbital assembly.
Orbital
there's
assembly.
a lot of people working in this discipline. There's also
Yeah.
OSAM2, which is in development by Redwire, and that's doing a lot more manufacturing. There's a ton of commercial companies that we have the pleasure of working with that are doing sort of either similar things to us or very different paradigms for servicing. Again, it's a really exciting discipline with a lot going on,
Orbital Assembly
but I don't know
wants to
that
build a
specific
space
thing.
Hotel.
Right.
So are you guys working on like a motel? Roadside assistance?
motel.
Space motel?
Yeah.
Roadside assistance, you got a flat tire, you got to pull over.
Not necessarily, but we do talk a lot about orbital hubs, like regional hubs, I guess. So establishing a hub in a region that can provide all these services to a bevy of satellites. So that would be sort of our version of that in the space superhighway paradigm.
Yeah.
Something else that just caught my eye actually on this poster is sample collection with a picture of the Perseverance rover.
Oh, yeah.
Uh-oh.
Talk to us about that.
That's a thing.
That's
So
a thing.
Mars Sample Return is in development by JPL. We're based at Goddard, but we are helping them out with some aspects of it. There's something called a Capture, Contain, Return system at CCRS. Really exciting work. I haven't really dug into it yet, but it's going to be a really cool mission. First time we bring samples back from Mars, truly going to change science.
And remind us of the timeline on that too. When are they thinking that might
That I don't know. That's outside my little world.
It's a while. It's a while.
Yeah.
I actually read something. One of the ideas behind it was that they were going to try to throw it like a football and then catch it. I don't know if that's possible. I also don't do sports ball, so I don't know. I don't know. Do any of us?
I'm still jumping around trying to find questions. I'm trying to get everybody's questions. but
We're
there's
live
no way
streaming.
that I
It's
can get
live.
them
It's
all.
loosey goosey, man.
It's too much for a phone to we're live on 4 or 5 different places right now, and I'm trying to switch between all the different chats finding questions.
Oh, yeah, no problem.
Yeah. I don't see any right now, but every now and then I lose the history, and so I can't read the question. Okay, we haven't missed much. Twitch says we haven't missed any questions, so good job, Twitch.
All right. Well, thank you so much for
no,
your
thank you.
time and explaining all of this to us. And I think actually we have somebody speaking about this at 3 o'clock.
Yes, Jill McGuire. She's my boss.
Jill
She's going to do an
McGuire.
amazing job.
Amazing. Great. So if you're local, still time to come on by and watch that 3 o'clock. Jill McGuire will be on stage talking about in-service assembly and manufacturing and assembly. Wait, I said it wrong. In-service servicing, assembly, and manufacturing.
It's a mouthful.
ISAM. That's why they have
ISAM.
acronyms. Hello. All right. Thank you so much again. It was great talking
Nice,
to you.
thank you. Thank you for holding the microphone. Very good job.
All right, so
All right, what
let's head
next?
on over here to the far side of the table.
All right. Moving right along. In true Kids Week fashion, hectically
And
running
if
around
anyone has any
interviewing as many people
questions-
as we can. Interviewing? I don't even feel like we're interviewing them. We're just chatting with them. Thank goodness we have Alicia here to shepherd us around.
I know a little bit about what's going on today. Just a little bit.
All right. Again, hey, y'all, if you have questions for us, I'm trying to read the different chats. I can't catch them all because I'm jumping from place to place. But I do have the YouTube chat here open right now. And if you have questions for them, paste them up so that we can ask them. Well, let's see who we're going to talk to next.
All right, so here we have with us LCRD, Laser Communications Relay Demonstration. Another mouthful. All these acronyms. NASA loves acronyms. So, ladies, tell us a little bit about what your division is all about and what you guys do.
Sure. So my name is Kate, and I work for NASA's Space Communications and Navigation Program, also known as SCAN. We are in charge of the Near Space Network and the Deep Space Network, which are NASA's 2 networks that communicate, talk to, and support almost all of NASA's missions. Human missions, science missions, search and rescue efforts. And we also do technology development. So what's the next generation of communications system? So LCRD, or Laser Communications Relay Demonstration, this launched in December 2021. It's going to be using the infrared end of the spectrum, a system that uses optical comms to talk to Earth, and also in the future to a payload on the space station. We're really excited about this because it allows us to get more data faster. It is, we'll say, in a less crowded end of the electromagnetic spectrum compared to radio waves, which is what we traditionally use. And it's just a super cool technology. And I'll let Corinne here talk about some other laser demonstrations. She's kind of our guru here today.
Oh, thank you, Kate. So LCRD launched in 2019. We're very excited about it. It is, as the name suggests, a demonstration, so to make sure that we can use optical in the future. Kate did a great job of explaining so much about what makes optical an awesome possibility. The other thing, of course, is that it's lighter, so ideally we'll be able to launch things for less money, but also be able to put more science up with those launches, which is really cool. This year, we should have our Illuma T launch. I have this guy to show you, which will join the International Space Station. And Illuma T is the integrated LCRD low Earth orbit user modem and amplifier terminal. All that means is just we're making sure that the relay between these different pieces of optical transmission can work well. So the hope is to establish an actual functional relay. We're really excited. We should be able to see that happen aboard the ISS by the end of this year.
So exciting. What a mouthful, too. I'm so
How
impressed you just
do
said
you remember that? Do you have to practice?
Sometimes.
So I am over here looking at my phone because we've got viewers that are watching asking questions.
Oh, wow.
So I'm not ignoring y'all. I'm actually reading questions from chat. So let me see if we can grab some. Why would you bother with laser communications? Don't we have radios that work fine and you don't have to point them very well? Do we need to upgrade what we're doing? What's the importance of it?
Wonderful question. I guess we'll answer this together. You tell me if I miss anything, Kate. But part of it is that radio does work really well. So many folks use radio that it's actually a really, really crowded level of the spectrum. So part of optical is hopefully, because again you can pack more data kind of into a narrower wavelength, we'll be able to kind of have more data. It's not faster, but it is denser in terms of technology, and then also just a lot less crowded. So ideally we'll be able to have a lot more happen. Did I do a good job there, Kate?
Yeah, you did an excellent job. There are a lot of, we'll say, engineering requirement type of benefits to using laser communications. One, a system that uses optical communications or laser, I'm using them interchangeably, but they're the same, is usually less mass than a radio frequency system and requires less power. Those are two things we love on a spacecraft. The most expensive part of spaceflight is launching, right? So less mass, that's amazing. Less power, it means it'll last longer. Another benefit is we like to say at SCAN, we like to serve the science community. It's important that we can ensure the health and safety of our spacecraft and our crew on our spacecraft, but for humanity's full benefit, we want to get as much science data down. It just sits sometimes in space until we can get a pass on Earth. So laser communications give us the benefit of the difference between dial-up and fiber optical communications on the ground. Really, it's a big game changer in that way.
And you don't have to hear the
screeching
sounds,
You
right?
should make it play that. Just
you have
because,
to insert your own sound effects. Yeah.
Back in my day.
Yeah.
So how resilient are these sorts of communications to being aimed or booped, I guess would be the way to say it. Not aimed exactly right. Something's on the station or something, and it's pointed at a terminal or receiver or something, and the spacecraft docks. And does that little vibration knock it off? Is it noticeable?
Yeah, so one of the challenges of using optical communications is your position, navigation, and timing with your receivers and transmitters has to be a lot more accurate. So that's part of our, we'll say, speed bump in the road of how do we make this a super efficient system in the way that we can make it as reliable as Radiocom. So to answer your question, interference is a little bit more possible when it comes to spacecraft movement or even things like the atmosphere. If we're talking to the ground, clouds actually will interfere with optical communications.
Right.
So we want to put our ground stations where there's usually less clouds. So that is another challenge. But part of these demonstration missions means that we get to figure out all those problems now and how we're going to solve them.
Gotcha.
Is the signal better, though, I would think? Because with radio waves, they would kind of spread and kind of get a little garbled the further they go, right? So with lasers, does it help to have that kind of line of sight?
Distances typically need to be a little bit shorter for laser comms, but it does mean it's the relay is less. So there's, let's say you're doing moon to the space station to Earth. With radio waves, it might take a little bit longer. With laser, it's a little bit more instantaneous. So it's kind of like you're outweighing the we'll say the wobbly. It's not scientific.
Right, that's fine.
Wibbly wobbly timey wimey.
Yeah.
So I'm envisioning a flashlight, right? So we know what a laser beam looks like, a really fine point of light, like really collimated, or whatever the right terminology is, right? And we have wider things like radio. Is there a wider laser? Like, you know, a flashlight, how you pull the front of it and it goes from the wide beam to the narrow beam? Or is it like multiple lasers? Or is it the laser in combination with the radio? Like, how do you keep, like, you talk to the spacecraft first and you get the broad, I guess, communication with it, and then you fine tune it. Like, how does that work? How do you get it to point correctly? Do you need to use some other system first?
That's a great question.
It's a lot of questions, sorry.
Yeah, no. So in answer to the one thing, in terms of wider lasers, yes, in the same way that radio broadens out, laser broadens out too over time. It's just that, like, the broadening is smaller, right?
Right.
So we do have, like, a little bit of leeway there in terms of, like, where the laser will hit. But it's much more marginal. So you have to do a lot more math, basically, in order to make sure that happens.
Right.
And it is, like, again, like, point to point, end to end. So that does mean, like, relays will be essential in terms of, like, making sure that this technology both can go further but also can connect to different angles. We need something in space that can do that and redirect it, sort of like the way having the ability to have mirrors that can reflect different things work. It's not, the relay is not a mirror, but It is kind of a data transmitter in that way. So if we can do that in space, that's great, because of course we can't really control very well where the Earth's positioning is for our ground stations, or even necessarily make sure that ISS, the International Space Station, is in exactly the right place. But we can make sure that our relays are in a good place to make that switch happen for us.
Gotcha. And
I hope that answered your question.
No, that answers the question. You said that it's more like relays, like a network of relays over shorter distances, not like one mega laser on the moon that points back at Earth.
Exactly.
Because as the Earth turns around, you have to have different... It's not always going to be in line of sight, right?
That's exactly right, yeah.
What can we get from these sorts of communications that we can't do right now, like the limitations we have with RF, radio, whatever? Why is this... The question is, why is this better?
Why is it better? We might tag team this as well, but one of the things is, again, it doesn't move faster, but because it's that narrower field, we can pack more information basically in the same amount of time, which can be huge. For instance, if we're going further away, we need to be able to talk to our crew. We also need to be able to have information back quickly. Like Kate said, sometimes we have awesome video or images from the James Webb Space Telescope, and we have to wait to get them back. With optical, ideally, we'll be able to have less of that delay. If something happens, say, in space, and we need to know about it, we'll be able to find out faster. So those are some of the ideas. So again, not faster in terms of speed, but denser in terms of data.
Because radio waves travel at basically the speed of light, right?
Yes.
And I think
it is
different medium or whatever. I don't know. I'm not a scientist, but it's not like going to get us half the time to talk to Mars or whatever. It's just more data because it's more power, I guess, per square inch or whatever. I don't know.
Perfectly summarized.
Okay, cool.
More data, more better.
Isn't
that what Jack says?
Yeah, I'll just say, like, it's kind of like if we were driving our 2023. I don't know. I drive a 4Runner. We'll just say that on a Roman road. Great roads. They worked really well.
Yeah.
Advanced for their time, but I'd love to drive it on an asphalt highway that's smooth and a lot more direct, and it gets me where I'm going, and there's less traffic, and I can go as fast as I want. I think it's kind of like, why not? Why wouldn't we do that? We're making advances in other systems on our spacecraft, like cameras that can take pictures like James Webb, or power systems and propulsion systems that get us places further and faster. So we need to also upgrade our communication systems. And I'll just caveat that to say this isn't meant to be a replacement to radio frequency systems. And the best way it would be a supplemental system on a spacecraft. So we had both.
More tools for us to use, like more options for us.
Yeah, exactly.
So you mentioned on spacecrafts, but what about, like, once we have maybe a moon base or Mars base or who knows where?
So glad you asked.
Okay, tell me.
Yeah. Lunar laser communications would be a huge asset. One, there's no atmosphere on the moon, so we've taken away that constraint of Earth-based laser communications. Another benefit is that, one, sometimes if we're going to be exploring the South Pole region of the moon, which is of major interest to us at NASA and humanity, we're not always going to be in view of the Earth, so that relay architecture is really important, and laser can work really well in a relay architecture for the communications.
We're getting all sorts of wacky ideas from chat now. And they're like, could you send I'm just going to say it because it's funny. Could you send another upgraded satellite that sits next to an existing satellite and listens to its radio communications and then uses its laser beam to send, like, not something you're working on right now?
Not specifically, but I will say there are efforts and ideas to outfit older satellites or space junk that is in an orbit with like a laser communications receiver and transmitter, because they're really small. They are really, this T-bird is the size of a tissue box.
Really?
And so if you had a way to outfit that as literally a cell phone tower in space, it's a dead piece of something or a really old satellite, but it has space for something like that, and it's at a waypoint that would be really beneficial. You can get a spacecraft there, attach it, now you have a cell phone tower in space.
And so like CubeSats then?
Yeah, absolutely, yeah.
I like that cell phone tower in space, like just improving the signal by putting little waypoints, relays, whatever you want to call them.
Exactly, yeah.
Nice. In chat, people also pointing out, oh, sorry, gotta go. Okay. Lisa's going off to do her next presentation. People also saying there's a security thing, because this is like expanse. Oh, we're going to do a tight beam communication, and it's harder to intercept because we just have a laser going to one point. Is that a part of it as well? Like, I guess you're not spreading the energy all over the place, so you get more energy in one little spot, but because you're not just broadcasting it everywhere, it's harder to intercept. Something you care about or not?
Oh, yeah.
Very much so.
Okay.
So actually, the other thing that both Kate and I are involved in is our intern program. We've actually had interns working on cybersecurity with lasers. So yeah, in terms of being able to have more data, we can also do a lot better at detecting when someone has interfered with a laser communication versus a radio communication. But you're totally right that being able to like have that narrower field does allow us to make sure that our information is, if not more secure, at least we have a better sense of if somebody else has gone in and seen it, which helps us too.
Gotcha. It's like, go ahead.
Well, I was going to say, I'm going to use a buzzword. Our favorite word at SCAN right now is quantum communications.
Quantum communications?
So what does that mean? Everybody's quantum, that's over my head. Don't worry, it's over all of our heads. The important thing about quantum communications is what does it mean for us in our day-to-day lives? Quantum communications, the idea of like quantum mechanics, to secure our optical communication systems is the key to like enhance security when it comes to communication systems.
Right.
As we get to a point where people are using quantum systems to, we'll say like attack networks or do this or that, you have to have the similar like defense. So we have a lot of folks at SCAN, interns included, and like extremely smart scientists and researchers studying quantum communications for applications with laser communication systems. So when you talk about like all the math it takes to accurately point our systems and transmitters and receivers, when we apply quantum mechanics to that, it's going to like take us to this next level. And a huge part of that benefit is the security part of it. It's like increasing our cybersecurity.
Gotcha. So you're talking about quantum computing in terms of like stronger encryption and stuff like that. Not like quantum entanglement where it's like two magical things that instantly transmit.
At the application level, no, but from the understanding level, yes.
Gotcha. We talked a little bit about, and again, I feel so weird because I'm like reading questions from the internet, but we talked a little bit about what this enables that we don't currently have because we have more bandwidth, right? It's smaller, it's lighter, it's more secure, it's hard to intercept, but it also, like right now, gives us more bandwidth over traditional radio communications. Is that fair to say?
It is. I suppose so. In terms of like how busy that area of like the spectrum is, yes. Not necessarily in the traditional like internet bandwidth way.
Yeah, we'll say a lot of folks will say fighting for the resource. If we use radio waves in the terms of resource, which really it is in this day and age,
right?
There are just a lot more players, and you can only allocate so much time to certain bands of the wavelength. And so it's not just NASA in the U.S., it's every country, every space agency, every military, every commercial company that's now joining. And it's a heavily regulated band of the spectrum. Infrared is sort of we'll say a Wild West. It's very exciting, and yeah, it just sort of allows for a little bit more like movement and movement around.
Gotcha. It makes sense. One more question, and then I know that the presentation is going to start here. Now I forgot what the question was supposed to be. Where did it go? Oh no, I had the question. It was about So, can I see these lasers? Like, when the laser is coming down from the space, am I in my backyard and I'm like, well, there's the communication from the relay, like you see a beam shining down from space?
They're totally invisible.
Right.
And we actually have a podcast. I'm going to pitch our podcast
Pitch
right
the podcast,
now.
nice.
Called The Invisible Network, because you can't see radio waves either. We are at SCAN sort of in the background of what we do at NASA. We are the network, the Invisible Network, supporting the NASA mission.
Gotcha. Yeah. But you can't, like, go outside and, like, look up and see.
No.
So it's not... Is it so much power that it could, like, hurt you if you looked up and you didn't know it was there?
No, and the important part of the, like, pointing navigation and timing system is that, for instance, we have, like, radio antennas on the ground, these big dishes, right? The receiver for optical comms is right in the middle. It's a fraction of that whole semi-spherical antenna, right? And so we're only pointing at that tiny, tiny point, let's say like my thumb, for 5 minutes, something like that, in a secure area.
Gotcha.
So it's really not even pointed at the Earth for a long period.
So it's not like there's just communication lasers in space that are just pointed at my house. I don't have a receiver at my house.
Correct. And it is, when we say lasers, we mean the infrared end of the spectrum, right? And so we have infrared energy all around us all the time. And it's just light, really.
Gotcha. That's like, so we say infrared, it's not a laser like a laser pointer that a cat would chase around.
Yes,
a cat would not have a lot of fun with an infrared laser.
No.
Well, now somebody in chat's going to probably correct me and be like, actually, cats can, like, I don't know if they'll say that or not. I don't know if it's true. I know the next presentation is going to start up here, so thank you all so much for the time. We
Thanks
appreciate
for the great questions.
Answering all of our wacky questions.
Anytime.
Cool. All right. Thanks, y'all. Yeah. So there is another presentation that's going to happen, and I think what we're going to do is go up to our little lookout nest and see what we can see. I don't know. I'm going to have to check to see if we can stream the next presentation or not, because some of them we can and some of them we can't. But at least as doing the intro, we're going to take like a little bit of a break and just sort of point the camera out and figure out what the plan is next. Are you putting any lasers on sharks? No lasers on sharks. They asked the question, sorry. No lasers on sharks. They're not going to shoot at Santa Claus either. Seriously, people? Ask good questions.
Don't you want to hear about it?
I think we will just go up to our lookout real quick. I'm trying to see if Alicia is walking around looking for us. Oh, she's right there, actually. So I'm going to step away for a second, just point the camera wherever. I'm taking the mics with me, so you probably won't be able to hear anything, but let me go see what the plan is. I think it's unmuted now. Did you press your button?
Hello.
All right, cool. I think we're good.
Let's move on.
We have more people to talk to, so. I love how organized this is. We're coming. All
right. This is a great stream. Thank you for joining us, everyone. We're having such a good time. Oh, perfect. Here we go. All right, ladies. Hi, so we are here highlighting some of the amazing booths. Do you recognize a face here?
I recognize it. Would you like a microphone?
Sure. That's so pretty.
Just sort of talk to it, yeah.
Okay, it's nice and fluffy.
So this is Holly Ellis. She has been so amazing with us at the Intrepid for so many years now. We love having you guys here all the time. And she really helps us out with the Astro Live shows too. If you tuned in for the Lofted program, she was really helpful with getting us some of those speakers, and we loved hearing about, didn't you have one out here, a little Lofted?
Yeah. Oh, I did. Where did he go?
Oh, it's over there. There you go.
There he is.
Amazing.
Yes.
Lofted. So we would love to just hear about what's going on with the technology demonstration missions. And,
Absolutely.
They all disappeared. Some of the other people that were here, what they are up to and what you guys
Absolutely.
are doing.
Well, this is our newest, our pride and joy. This is Lofted, or a low orbit inflatable decelerator, and this was launched back in November, and this is going to be what gets us to Moon and Mars a little bit safer, and it also has the potential to return things from space, do the padding and the deceleration process. But we're kind of here just talking about anything new, technology oriented, and in particular, we are really talking about, this is the big catch of the day. This is our new graphic novel that was designed and developed at STMD, which is the Space Technology Mission Directorate, and it tells the story of Callie Rodriguez. And Callie is an African-American Latino lady who wants to grow up and become an astronaut. And it talks about all of her adventures and what it takes to become an astronaut. And the best part, I think, is she designs her own robot, and his name is RT. And he's always into some kind of trouble. But it's a great storyline. It's a very interactive novel. It actually has QR codes throughout the book that you can scan over, and it will take you to the technology we're talking about in the story. So you can really see what it's going to take to get to Moon and to Mars. So we're very proud of this. And we also just recently released, it's so hot off the press that we don't have the printed copy, much like last year. We got the book this year. Now we don't have the STEM guide this year, but this is our STEM activity workbook. You can scan a QR code, and you can really do some fun experiments that dial back to some of our newest technologies, which deal with space communication, laser devices. We also, over here to the left, you're going to see a ton of our robotics that are on display. We're presently working on a project called OSAM-1, which they are challenged with going out and servicing and adding fuel to satellites that have been decommissioned for a really long time. So we're hoping to bring those things back into working order, but it's very complicated. Space is difficult. Over here to our left, we also have some of our friends in the space communications area, and they're talking to you about the latest and greatest with optical comms and using lasers to transfer information from outer space to us quickly.
We just actually spoke with them too. Some really fascinating stuff going
on.
So back to this comic real fast though.
Yes.
So if they're not here and you can't get an in-person copy in your hands, how can people find this comic at home if they're just on the internet right now?
Let me read it out to you. It is, go to nasa.gov/specials/Callie First.
Zoom in on that.
Zoom in on it. And I think if you Google NASA and Callie, you should be able to go straight to it. And yes, we're in the process of updating our entire website. Stay tuned, probably in the next 3 months. NASA is going to have an amazing new base for technology.
So regarding Lofted then, since we did just talk to you guys in, November?
Yes.
I think on Lofted.
Yes.
Any updates for Lofted?
Well, about a couple of weeks ago, we reinflated it, and it is amazing. So far, everything works really well.
That's good.
I'm not an engineer. I'm not going to be the one to provide the final report, but we were very, very pleased with the activity. So right now what they're doing is they're going back through and they're looking to see what kind of damage was done to the actual return vehicle. And hopefully we're going to get a really good report in the next couple of months, and they'll be able to take that new technology. And ULA is very excited about the possibility of being able to use this technology to return their rockets, so that they can have more reusable devices with all these missions. I mean, we're constantly sending something to space just about every day. So the more sustainable, this is going to be a really good first step.
And just remind everyone, if they didn't tune in to the Astro Live, which you can still do, by the way, it's archived on the site.
Amazing.
If they weren't there to hear about Lofted, remind us what Lofted is and what the kind of future goals. Obviously, we have ULA returning, their boosters. Are there other things that might?
Our long-term big audacious goal is this is what will help us to get to Mars. Because if you can imagine, Mars does not have an atmosphere like ours. So we need something that's going to not only slow down the aircraft, but it's going to give it a soft landing. And so it is a decelerator. And we were looking for something that is also reusable so that we can use it for other things. Once we get to Mars, there's going to be a lot of things that we're going to have to do once we get there. So this was a really huge positive step in the right direction of figuring out how we're going to conquer that lack of atmosphere on Mars. So I'm very excited about it.
Nice. There's no questions yet. I'm like, I'm looking at my phone because the people
No
are asking
questions.
Ask questions, people.
No, I remember that the conversation was so fascinating, and really looking at this thing, it's like Captain America's shield. Like, it's literally a heat shield.
Well, it was so funny that some of the first tweets, this actually, the day that it launched, we were so excited because it was in the middle of the night. How do you make something interesting that's going to be coming in the middle of the night, in the middle of the ocean? Nobody can really see it, but we were able to get, Sci-Fi was able to capture a lot of the activity, and it looked like a UFO. It really did. It was like glowing in the dark. You had this infrared video that we were able to capture. It was totally fascinating. And then as it landed, it looked like it was on fire, and it really was. It was the heat that was radiating from that heat shield, even as it hit the water, and it remained glowing for so long. I mean, watch the video. I highly recommend it. It was really, really cool watching it come in. And but yeah, that was a big win for us. We were so surprised, but the picture really does tell the story, and everyone was fascinated. It was a top 5 tweet for that day. So it's really...
People said thanks for showing it, because a lot of times, like tests like that or missions like that, they happen and then they get recovered.
I know.
And y'all had video of it, and it was being tweeted out, and thank you for making those sorts of things accessible, because it lets more people know what's going on. People in chat aren't asking questions; they're saying thank you for sharing it.
It was really fascinating. And I would like to say it was all because of me, but it wasn't. No, those folks
it was
down
a lot because of you. You did communication.
Those folks down at KFC, they know what they are doing. I mean, they were just moving and shaking, and we got delayed as well. So we were all ready, set to go on the coast of California. Then we had our people in Hawaii, and it got dialed back. And it was just something so slight that they saw that was off. So it got delayed a couple of weeks. So
that's the name of
the game. They have to stay in Hawaii for a couple of weeks?
I know, really?
Oh, no, it's terrible.
That was terrible. Although, I don't know, 3 hours on a tugboat floating out in the middle of the ocean.
Less
I'm not
fun.
I don't think that would have been very fun. So.
And yeah, speaking of the ocean, though, so the other cool thing about Lofted is it's inflatable. And you had that amazing footage of it actually,
blowing up.
From the spacecraft.
Yes. They caught it as it released from the Centaur. They were able to catch this amazing video footage that actually was developed at Marshall Space Flight Center. So, which is so interesting. We are housed at Marshall.
Yep.
The project was based out of Langley, but yet some pieces and parts have been made at all the centers across the country. And then there's also, of course, ULA is a commercial element. So it was a really neat partnership collaboration, and it really goes to show this is how we have to work together to move forward. So
that's a recurring theme that we're definitely noticing
yes, it is.
around
it takes
with
all
everyone.
Of us.
Partnerships.
It takes all of us. Yes.
Very important.
Again, I'm just reading questions. Were there any unexpected twists or anything like that with working, I guess, specifically with Lofted?
They don't tell me those things.
They don't tell her those things. There you go.
Don't ever give me the chance to let it slip, right?
I just make it look pretty. That's
it's
it.
I just make it look pretty nice. Let's see here. I'm trying to see. Yeah, some things we talked about when we did the Astronomy Live, because people asking could it be a lifeboat for astronauts to ride down? And we asked all those questions. And this was a technology demonstrator. Like we said on the stream, this was, does it work or not?
Exactly.
Is this an actual idea that we could leverage or use in other ways? That's the whole technology demonstrator missions. I read the sign.
Yes, exactly. Well, if you can imagine when this has been in the works for 11 years. The whole idea, concept, it goes through this technology development timeline. And, as you reach certain milestones, you can kind of move up the chain. But the goal is you want to make it to our department, technology demonstration missions. That is where we're saying, okay, this is a viable technology. We've done the research. We really think it's going to work, so let's fly it. Or a lot of times we'll ground test it. So, yeah, once we reach to that point, We're good to go.
It looks good.
Yeah.
And what are some other technology demonstrations that have fared super well that you could tell people about?
Yes, well, right next door here, we did LCRD, which was the laser comm relay device. That was a really interesting, fun, necessary technology. The laser comm relay device or I say device, it was a relay demonstration. It was testing. We need to find ways to bring larger amounts of data back from space, right? We're still using radio waves, but how are we going to get a better quality, larger quantity coming back? So they figured out a way to use lasers to make it happen. And then also, it's kind of, if you can imagine, like that little game of telephone, where you pass the conversation down from one person to the next. We have to really relay that information and find ways through satellites to get it as far as it needs to go. And we had really 2 ground stations that we devised off the coast of Hawaii and one off the coast of California that we felt like were points that had the least amount of cloud cover, a lot of research as you can imagine, so that those lasers could have an unobstructed view with the satellite. So those types of processes are really starting to teach us more of what we can and can't do. And they're in the final stages. Once we demonstrated that it would work, it got transferred over to the scan department, and they're kind of tracking all that data. So that's a really fascinating one, and we're also going to go a little bit further out into space with the Deep Space Optical Communications demonstration, which is scheduled to go out on the Psyche mission. I don't know if y'all talked to the Psyche folks yet, but we're going to pitch a ride with Psyche in October. And and that's going to take us into deep space, and that's going to be really interesting to see how that works. So, yeah, lots of good stuff.
Good deal. I mean, it's what we say over and over again. Like, it's not just about the rocket launch. Like, everybody gets so excited about, hey, a rocket launch. Okay, great. Okay, it's over. Like, all the little pieces, like your background here shows, all the different things that you have to work on in order to make a mission successful, so the rockets have something to do.
Oh, let me show you something cool.
Yes.
This right here.
Yeah.
That is Moxie. Have you heard of Moxie?
Yep.
Yes. Moxie is such a cool little bitty box that they put on the Perseverance rover that is testing, taking carbon dioxide and turning it into oxygen, because obviously we need to be able to breathe when we get them.
Yep.
That little box works, and it works really well.
It works.
It works, and it works really well. And we are very excited because they feel that we can scale that to the next level. And obviously, more oxygen. Obviously, we need that to breathe, but we also need it for our fuel.
Yep.
That's how we fuel these things.
Yep.
What else have we got? Well, that's our LCRD. We've got, there's a little Percy right here.
Yep, Perseverance, yep.
Oh, gosh. That right here is kind of an idea of what they feel like the power stations are going to look like when we get to Moon. So they're testing lots of different ways of creating power grids on the Moon. So that's kind of an idea of what they feel like that's going to work.
I thought it was a moisture farm, maybe.
Who knows? I mean, it's crazy. I mean, the ideas they come up with every day is just fascinating to me.
But it really is so important. Like, it's not just about the rockets. The rockets need to have things to do, and all the little systems and all the little components and all the things that we're sort of learning to improve, that's what y'all do.
Yeah. Space is hard.
Space is hard.
Space is hard.
Nice.
Yes, that's it. That's it. I know.
Cool. I think I've asked most of the questions that have come through here. Again, folks, if you're listening to us, I'm like literally. I think the people we're talking to might think I'm rude sometimes because I'm looking at my phone while you're talking. I'm so self-conscious about looking at my phone while you're talking, but I'm reading questions from chat. So I think we've gotten. What's questions about Moxie? I mean, Moxie already works. Yeah. It's not an idea. It's there and it's already working.
It's working. It's
right?
working. They've run, I want to say, don't quote me on it, but I know we've done at least a dozen runs. And we initially had not planned to do but a handful, like 3 or 4 turns. But because the timing has been right, the energy, the battery has allowed us to continue going and continue testing. So it's very exciting.
And is the idea with Moxie, just to remind people again, is it to be put in like a habitable space, or is it something that would be in someone's space suit to make them be able to, go out into the environment more?
I think at this point it's really just the technology.
Yeah.
Right. Let's test, let's figure out how that we can collect it and what's the quality of the oxygen that we're getting back. And, again, in hopes to make it scalable, We're going to need a lot more than this little guy can put out. So,
Yep.
but yeah, just creating that technology.
Gotcha. Good. Well, chat, I think we've asked all the questions that have come through. Once again, thank you so much.
Thanks, guys.
I know we're like super like, oh, let's just run around and talk to people, but it's fun.
Holly's a good sport, though.
Yeah.
I love it. It's so much fun. This is such a great event. Thank you for having us.
Of course, thank you for coming every year.
It's
Holly's
great
the
fun.
best, guys.
Great
Holly
fun.
Ellis.
All right.
There you go.
I
All
like
right.
it.
Thank you. I'll take the microphone back.
Thank you.
Thank you.
I mean, there's so much stuff going on. Do we want to talk a little to Blue Origin Club for the Future?
Can we talk to them? Did you talk to them yet?
I did. This is Logan. Let's go
All
talk
right,
to
we're going to go
Logan.
talk to Blue. They never talk to us. Is it Blue Origin or is it Blue Man Group?
Well, we can talk to Blue Man Group
this
if you want.
both.
They're right over there. Ooh, hello.
Welcome to Kids Week.
Yep.
It is. Give us just a second. We'll get
As
this set up.
promised, we're back. So this is Logan Hepburn. Hello.
Here.
And
Can I hand you a microphone? Can you tell us about
sure.
Club for the Future?
There we go.
you go. Sure.
So this is Blue Origin Club for the Future.
Hi.
Tell us a little bit about what Club for the Future is all about.
Yeah, so Club for the Future is Blue Origin's nonprofit. We're here talking to all the kids that are here for the event this weekend, and we're writing postcards. So every kid here has the opportunity to address a postcard to themselves, decorate it as they please, and we send it up into space past the Kármán line on our New Shepard launch vehicle. So we're here talking to kids and talking to them about space and what inspires them about space.
And can you tell us a little bit about this thing right here and how that's involved?
Yeah, so this is our model of our New Shepard rocket. It's our suborbital class launch vehicle powered by the E3PM engine. And so this goes up into space. We load the crew capsule with the postcards and whatever cargo are allocated for that mission, sends it up into space, past the Kármán line, and then when it detaches or floats back down, we collect the postcards and sell them out to the kids. Or, send them out to the kids.
It says sell them back to the kids. Nice.
No. Yeah, exactly.
Send them back
no.
to the kids.
I mixed mail and send, and it kind of got out. But yeah, we mail them out.
This is free. This is free.
This is free.
So it's an opportunity for the kids to have something that went to space.
Absolutely. It's a great opportunity for them to have a nice little souvenir, something that's actually gone to outer space.
Nice.
That's so cool. Is there a way that people can do this from home if they can't be here on
Yes.
site to make one of your, pre-made
Yes, in
postcards
fact,
here? How can they do that?
Yeah, so if you go on to Club for the Future's website, we have a printable version where you can print them off, and you just postage it and send it to our location out in Van Horn, Texas, and we'll collect it and send it back to you. The directions are all included online with the printable version as well.
That's so cool.
No kidding. So like anybody can put together a postcard and
Oh, yeah.
register or whatever. Even me.
Exactly. You know, we like to talk to the kids about it, but there is no age restriction. I've done one. She's done one.
No
Yeah,
kidding.
we like to really encourage everyone who wants to be involved and is interested in space to actually do one.
It's for kids and kids at heart.
Kids at
Exactly.
heart.
Aren't we all?
Yeah, of course. Hello. What is the turnaround time? Just out of curiosity, do you send them up on every Blue Origin rocket that goes up, or is it just going to be one that's going to be going up, doing all of them at once? Or?
Yeah, so, we send them up as soon as there's availability to do so. So that can vary based off of launch schedule and capacity, but we send them off as regularly as possible. So there's a consistent flow. It doesn't stop.
That's so cool. What are some of the other things that Club for the Future does? What are you guys all about?
We like to talk to kids and talk to them about space, so we'll do outreach out at different local elementary schools, all through K through 12, and we promote different types of STEM topics and really try to get them involved about the topic of space, the future of space, and their role in it.
That's exciting. We're all excited about the future of space, I think. What are you most excited about
Oh.
with the future of space?
Probably the accessibility, as we kind of progress in the industry to make things more affordable and the regular spaceflight turnaround more and more, the accessibility is going to just continue to skyrocket, and you're going to see more access for not just the astronauts that have been part of NASA, but that are going to expand into the private industry, into commercialized different markets, so that's what I'm excited for.
Do you know anything about what Blue Origin's up to these days? Like, are you able to talk about anything?
That's highly classified, I'm sorry.
I just thought I'd ask, Do we have any questions from...
So we're working on getting a link to the website
Yeah.
so the people that are watching can check out the website and see what Couple of Futures is all about and that sort of thing. That's going to happen shortly. Give us just a second to get the website in here. That is what they're doing here. Like, you have postcards on the table
Yes.
at Kids Week, and
Yeah.
kids who are here at Intrepid can come up and fill out a postcard.
Yes, absolutely. That's exactly what we're doing.
That's what you're doing right now. That's why there's the markers and everything on the table.
Exactly. Help yourselves. You're all so welcome.
So if you can't answer, just be like, But do you work for Blue Origin, or do you work for Club for the Future, or how does, like, are you an engineer
Yes.
that spends time with Club for the Future, or how does that shake out?
Yes, so I'm an engineer at Blue Origin, and I'm an ambassador on Club of the Future, so it's our nonprofit, and I volunteer at events like these.
No kidding. Are you based here? Like, did you travel to New York to do this sort of thing?
I traveled to New York for this. I'm based in Huntsville, Alabama.
No kidding. Have you done a lot of things like this, where you go and?
I haven't had the opportunity to do too many since I'm relatively new.
Yeah.
But I am signed up for several more in Huntsville area coming up shortly this quarter.
Excellent.
Rosemary, who was just over here, is actually local. Oh, she is. She's local here. Doesn't live too far from Intrepid, actually, which is great to have her.
Yes.
So you said you're an engineer for Blue Origin. I know
Yes.
you can't tell us too much, but what do you do as an engineer for Blue Origin?
Generally.
Type of engineer you are.
Generally. I'm one of our test process and manufacturing engineers, so I'm one of their engineers for the engines that we develop, and I work on operations for that, for the actual test operations.
Nice. And you're here at Intrepid talking to the kids.
Absolutely. You know, a lot of them have a lot of questions. I'm really happy that I get to be here and try to happy to answer those and entertain those as much as I can.
Nice. You get the kids come up and they're like, oh, it goes to space. Da, da, da. Oh, what's the status of the BE4 engine? Like,
you know, I have not been hit with that one yet. I've been hit with is this actually going to space? I've gotten that one a lot, and I'm like, yes, it actually is. Yes.
Which is really cool.
Excellent. We're going to train some kids to come over here with some planted questions. Like,
Oh, yeah.
Little Timmy walks up like,
So this is also, she's here with them. Hello. You're local to New York City, right?
I am. I'm local to New York City.
Awesome. And what do you do?
So I'm in communications for Blue Origin.
Oh, great.
And Club for the Future, we're both club ambassadors, and our mission is to inspire kids to pursue STEM education, STEM careers, and become an engineer like Logan here. Anyone can work in space. You know, I wasn't the best student, and I work for a space company, so that we just want to make it possible for everybody to see that potential. And we do that through access, right? So we're lowering the cost of accessing space. Kids get to fill out postcards and get a little keepsake of a postcard, something that went to space. We have ambassadors like Logan sitting here going, hey, I'm doing this. This is what I'm doing, answering questions. And then access to partners and experts like NASA astronauts, also Blue Origin astronauts, people that have gone to space. So we're just so passionate about inspiring kids. And look, he's going to send this to space right now. So if you just put that in the mailbox here, and then we're going to get that on a future New Shepard mission.
Nice.
Just make sure it's on your address. Yeah, anything you want.
This is a question. Are y'all going to be here tomorrow?
Yes.
There are some people
I
that
will
want
be here
to...
tomorrow. I'll be here all 3 days.
No kidding. People want to actually come to the museum because they saw us here streaming saying what's going on. So
Great, yes, we'll be here all 3 days, so come make a postcard.
Excellent.
Awesome. Come make a postcard. Come see. We've got Jessica Watkins here tomorrow. We've got Mike Passamino, and hey, we'll be back too.
That's what I'm doing on my phone, by the way. I'm like reading questions.
I was wondering. I was like, I figured you were. That's so cool.
I thought it was Fruit Ninja, personally.
I was playing Fruit Ninja. Yeah, I'm over here swiping. I gotta feed my chickens. No, but thank y'all so much for doing this. Thank you for volunteering for Club for the Future.
Yes, yeah.
It's really awesome. Like, it's one of the things every time we see a New Shepard fly, to know that it's more accessible. Like, it's not just super science experiments and stuff. It's like postcards that kids send and they get back is almost as important as scientific experiments, because the kids are going to be doing it.
It's the next generation, though. That could be the thing that inspires someone to get into being an engineer like Logan. So make a postcard, get something from space, and become an engineer.
Yep.
Or a communications
Or
person.
communications.
Science
You can do
communications is very
that
important,
too.
too.
STEAM, right? The A in STEAM is arts.
A in STEAM.
Yes.
Excellent.
Super.
This is Club for the Future.
Thank you, guys.
We'll take the microphone. Thank y'all so much. Y'all are awesome. Okay, cool.
All right.
What's next?
And then we've got
She
over
knows
here
what's next.
the Amateur Astronomers Association. We love them. They come all the time for our events. Can I bounce in here?
Yes.
All right. So this is Katro. She's
Here.
amazing. Hello. She is also a NASA Solar System ambassador, just like me. So we geek out together. Can you tell us? We're live streaming right now, by the way. You're
Hello.
live. Can you tell us a little bit about the Amateur Astronomers Association?
Sure.
What you guys do, and a little about your observatory.
Thank you. So we are the Amateur Astronomers Association. We have been around since 1927, and we are based out of New York City. We do amateur astronomy through sidewalk astronomy. We have lectures, we have classes, and we just just get out and bring science and astronomy to the public at large. Light pollution, yes, it's an issue in New York City, but we promise we can make it work with the telescopes. You can always see the moon, you can always see the rings of Saturn, you can always see large star clusters from New York City. You just have to know how to look. And in May of this year, we'll be opening our first free public observatory in the Bronx in Jerome Park, and it'll be open to the public in working with the Parks Department and Bronx Science High School. So it'll be a domed observatory, and it'll be the first free observatory in 150 years.
Wait, what?
Yeah. It's the first free observatory New York City has had in 150 years.
No kidding.
Yeah, so there are observatories, Columbia has theirs, but it's with the school. And so this is for the public.
Okay.
And in doing that, there won't be as many limitations on when you can go visit, because Columbia has designated nights because it's on campus, and that's fair. But this, if the weather cooperates, will be a nearly 365 operation.
Gotcha. Because it is, I mean, people are like, oh, is it muted?
Oh.
There we go. Now my mic's unmuted. Okay. They should have a little light that lights up or something. They don't. So it's not like you said with the university where they may have like a night once a month or whatever.
Right.
It's just a public.
This will be public in a public park where people can come up and they can either go into the observatory to look through the main telescope.
Yep.
We will have 2 additional telescopes. One will be outside for ADA accessibility.
Right.
So anybody that maybe can't get into the dome because you do have to step down and in.
Right.
You can use the one that's outside, and it'll be comparable to the one that's inside.
Okay.
And then we also will have EAA, which is electronically assisted astronomy. So we will have a telescope hooked to a monitor for those that maybe have some visual impairments that can't really focus through the eyepiece. They'll mean a much larger screen, so we'll be able to provide that as well. And everything will be carbon neutral.
Okay. Like, what does that mean? There's going to be like a windmill outside powering it?
Solar. It'll all be solar. And just in case we do accidentally set a carbon footprint, we're planting some trees in the area as well to just offset that.
Okay, gotcha. It sounds like a big project. It's amazing.
It has been a year in the making, and we hope to break ground this spring with an opening in May.
Yeah.
So, fingers crossed.
No kidding. What other sorts of programs do y'all do with the amateur astronomers?
Sure. So we have a lecture series that we do once a month from October to May, and that's all free and online as well. If you go to our website, AAA.org, so AAA.org, not the cars, the telescopes. And we also do classes as well. So if you wanted to learn anything about amateur astronomy, if you wanted to learn about astrophotography, if you wanted to learn about cosmology and physics, we have a very wide range of classes that you can take online. And if you are in New York City and you decide to become a member, we have a telescope loaner program where you can borrow a telescope from our storage locker for 3 months at a time, and you're able to use it at will. So if it just happens to be that you wanted to go out and it's a clear night and maybe we aren't having an event, but you've borrowed one of our telescopes, you can go out on your own and do star hunting. And we have everything from manual to automatic. So there's a very wide range of telescopes that you can borrow.
No kidding. What was it? One of the mods. We always do this as we talk to different people. I'm reading chat, by the way.
Hello, chat.
Yes, she says hello, chat. One of the mods, get the website link and put in the website link. You said it was AAA.org.
Yes, .org.
Right?
So AAA.org, O-R-G.
If you see cars, you're doing it wrong.
If you see cars,
you're doing it wrong.
Nice.
So it's AAA.org.
It should look like that. Somebody get the. There we go. We got the link into chat.
There we go.
How are you funded?
We are 100% volunteer.
Right.
So we are a volunteer organization. We always have been since 1927. And everything that we do is either just out of our own time, but we do accept donations, of course.
Yep.
We are currently accepting donations for the observatory project as well, and that can be found on our website.
Nice.
But everything else is volunteer. So if you see us out and about at one of these events or at a library event or just on the sidewalk, it's all volunteer.
Nice. That was a setup, by the way. That's why I asked the question. So it's like, here's the link to the website, and if you can help us fund our telescope in the park.
It's such a great project, though. I'm so proud of you guys. It's
Thank
been
you so much.
It is. We're all really cheering.
It has been a real labor of love, and I just can't wait to see it done. I can't wait to see it finished.
Everybody said hi back to you, by the way. There's a little bit of a delay, but you said hi, and everybody said hi. Chat is saying you need to choose a side because you've got a meatball and you've got a worm on. You're like...
I'm going to be extremely controversial and say worm ball. And I know everybody says either worm or meatball. No, the answer is worm ball. Trust me.
Partnerships, right?
Exactly. It's all about collaboration.
It's all about collaboration. Nice. Y'all, if you have any other questions, I'll read a couple more questions out of here.
Did you already say what your next upcoming events are? And
So we do have some events coming up in February. We have one at Brooklyn. It's Floyd Bennett Field in Brooklyn. And that will be on May 24th. February 24th. February 25th will be at Great Kills in Staten Island, so Great Kills Park. And then the last Tuesday of February, that will be at Fort Greene, so near Brooklyn Tech High School if you happen to be in New York City. And all of that is found on the website. We do have events being regularly posted. It's just we're waiting for some venues to get back to us, but some of our events are already posted all the way out to December. So if you go to the calendar, you'll be able to see everything from the observing to classes to lectures, anything that we have going on.
And we have some events coming up at Intrepid as well.
We do.
Again, we love partnering
We
with
have
you guys.
2 astronomy nights happening with Intrepid, one in April and one in September. So if you happen to be at Intrepid, come find us. We're going to be on the flight deck.
And so will we.
Nice.
Not on the flight deck, but in the shuttle. On the flight deck, actually.
Yeah, you'll be inside the shuttle. We'll be outside with the telescopes.
It's fine. You can't see much from inside the pavilion. It's not great for
But they do solar observing, too.
We do. You are able to.
Cool.
We have telescopes that are able to look at the sun safely, and that is the key, safely. We have solar telescopes. We also have solar glasses, and a lot of this is just regular equipment that we have, but the solar glasses are going to be in preparation for the 2 solar eclipses we have coming up, one in October of this year, and then April of next year. So April 2024 is when we'll have our total solar eclipse. October of this year will be an annular solar eclipse. Annular is when you get that ring of fire. Total solar is when you have that complete blackout. So we are gathering all of our glasses to hand out to the public, but we'll also have solar telescopes on hand for any events that we have in the city.
And for people who are tuning in locally, where is the the closest place that they could go visit for the full total solar eclipse in 2024?
Oh, for the closest I would say would be probably upstate. But if you are in New York City, we're going to have close to 90% totality. So if you decide to stay put, it won't be a bad show.
Yeah.
Is NSF planning on streaming the solar eclipse?
Is NSF planning on streaming the solar eclipse?
Can I come?
Sure.
That sounds awesome.
Yeah.
Cool.
So we are starting to run really low on battery.
Oh,
That's
no.
what I was just looking at there. So before it just mysteriously dies and we can't say anything about it, we have a live stream fan here, it looks like. We are probably going to say thank you.
Thank you.
And remember the website, AAA.org.
Dot
Three
org.
A's, the letter A's, .org, to learn more. There's schedules and stuff there. You can help support the telescope or the observatory in the park. Thank you so much for hanging out with us.
Thank you for having us. Absolutely. Keep looking up.
Excellent. All right. So we're going to let's mosey over this way. Got a YouTube star there hopping in front of the stream. We can go up and plug in, and I'll probably just talk to them. But how many more? Do we have a lot more people we haven't talked to?
If there was any other last minute with the inflatable bouncy castle.
I can try to see. I can see what exactly the percentage is to see if we can run over there real quick. Let me check real quick. Do you want to give a spiel about Kids Week while I check the exact?
Okay, for those of you
Another
who are
Kids
just
Week
tuning
spiel.
in. So Kids Week is our big annual festival here at the Intrepid Museum. We like to say it's kind of like our Super Bowl, honestly. I mean, and you can see it's a big deal. This is only day 1, but it runs during the New York City schools midwinter break. So this is the time where kids are home from school, parents are like, got to do something with you. And so we, pull out all the stops and we provide a really fun, really educational experience for them where they can get thrilled and delighted with all sorts of fun, engaging activities. So the first 3 days are Space and NASA Days, as you can see, as we are going around highlighting today. And then after that, we've got Arts and Culture Days. So we have performances coming in. We've got authors coming in to do book signings. I don't know if you can hear that. We got R2D2 behind you now.
I should go hold the microphone up too.
Yeah. And then after that, we've got Science and Nature Days. We've got live animals coming in that you can see a kangaroo and an alligator, and then some engineering days too.
Nice. So we have just enough battery if we run right over there to talk to the Artemis folks. We can do that. We're using some new equipment. Are the transmitters good? All right, yeah. So we're sort of learning exactly how long the equipment lasts.
It's a technology demonstration.
It is. This is the NSF Technology Demonstration Department. Let's see. Are we here? We should stand in front of the bouncy castle.
All right. So this is Patricia Moore. Do you mind popping over? She's amazing.
Nice. I'll hand her the mic.
So, and what a great backdrop here. Our inflatable. We were calling it the SLS Bouncy Castle.
Oh yeah, we won't do any bouncing on it though.
So we're going around highlighting all of the different amazing partners that are here today, and we, Artemis, yes, big deal, right? Absolutely. We've been following for so many years. It launched. We were so excited.
Yes, it launched in November.
Oh my God!
It was
amazing. Yeah, a lot of the NSF crew was there too.
That's
it was
cool.
so incredible. But tell us about what you're talking about here.
Sure.
And a little bit about kind of the next phase of what's going on with Artemis 2 and 3 and
Definitely.
so on.
So we had an amazing test flight in November and December. Orion. Well, first of all, the rocket performed beautifully, and it pushed Orion in space. Orion went and spent 25 days in space and went around the moon, farther than any human-rated spacecraft has ever gone before. Everything was great, splashed down, and so now we're gearing up for Artemis 2, which is scheduled to happen in a couple of years. And this time we're going to go with crew. So we'll have 4 astronauts on board. They'll go and they'll orbit around the moon, and then they'll come back and splash down. And then about a year later, we'll have our first crew on the surface of the moon with Artemis 3. And we have a model, if you guys haven't seen it already, over there of the Starship. And SpaceX was selected and contracted by NASA to build our first human landing system. And so they'll get to fly on Artemis 3 and Artemis 4. And then each time from there, we're just going to go back to the moon, stay a little bit longer, put rovers on the moon. We've got our habitat team here that are experimenting with different materials that could possibly be used on an inflatable or expandable habitat. So a lot of exciting things happening with Artemis.
I'm gonna say real quick, the red team has already been here to the inflatable Artemis, and there is no hydrogen leaks.
No hydrogen leaks. Every now and then the curtain gets on the back end of our vents and then it begins to deflate. So we have to make sure the curtain's not in the way. But other than that, this inflatable has performed flawlessly today.
You send in the red team.
Yes, send in the red team.
to clear out the- Hey, it's chat. It's not me. I'm just reading what the internet says.
Yeah, so we're the red team. We run in and move the curtain anytime it starts to deflate. Yep.
You have the cameras watching you. It was really cool.
It was very cool.
Like, I have to say, one of the most impressive things was the fact that NASA shared that.
Yes.
And showed the red team going in and doing that work. It's not like, oh, shut it all down, it's going to be 2 more weeks.
Yeah.
Like, the specially trained people went in to actually crank a wrench. Like,
Yes, they cranked a wrench.
That was amazing that was shown.
Yeah, and then there's the people. First of all, we always celebrate the red team that goes out, but first of all, there was a team of folks that identified the problem and knew how to fix it. And then they have a whole team behind the scenes that a lot of time doesn't get recognized for all the work that they do. But somebody had to say, no, we don't need to scrub. We can fix this. And this is how you do it. And then they send out the team. Those people were kind of in behind the scenes, but there were a lot of folks that were there to support.
But thank goodness they were.
Yes.
Yeah.
Yes.
Because, there was a lot riding on that. We were all crossing our fingers and toes. And
Yes, I was there too. When we heard they were going in to fix it, everybody was cheering. It was very exciting. And then when they said they fixed it, we were cheering even more. Oh, it was amazing. Yeah.
Does the team that identified the problem have a name or a color?
I don't think they have a color. We could just call we have the back. We call them back room.
Okay.
So you have your folks that sit on console that are responsible for that particular piece of the launch.
Right.
And then you have a whole team of folks in a back room that are there scrubbing, scrubbing the numbers and looking at options. And then they advise the lead saying, okay, we think we've got it. This is what we should do. And then that person then reports back to the launch director.
I would imagine there'd be a lot of risk management people.
Well, everything that they do for launch is risk management.
Right.
There's risk in everything. And so they look at what is the risk, is this worthwhile? Can we do it? And they did it. They fixed it and it was great.
Nice. It's an interesting thing. Like, we see Mission Control and we see all the people sitting on console and they all have their little name tags, ADCO or whatever.
Yeah.
But each one of those people, they're not working alone.
No.
They have an entire team behind them that you don't get to see.
And the team is made up of NASA employees and our contractors. So the folks that were working on the rocket, you have folks from Boeing that are responsible for the engine, the core stage, Northrop Grumman with the boosters. We have the Jacobs team that was responsible for all the ground operations. And so there's a lot of NASA folks and our contract team all working together. Yeah.
So you see the rocket, and then you know there's the launch director in charge,
Yes.
Charlie.
Charlie,
And then
yep.
you see all the people sitting on console, but there's even more people behind
Yes.
the scenes. Just
Yes.
must be hundreds of people.
And there are a
involved.
lot of people. And then there's like even more people that got us to that one point.
Yeah.
So you get folks that sit on console, some behind the scenes, and then everybody else is watching and knowing that they contributed in different ways. Yeah.
That's
so
awesome.
Artemis 2
Yeah.
coming up. What can you tell us about that? I know they're about to announce who's going to be on it soon.
We don't have an exact date that's been released yet, but it's
been released yet.
yeah, but it's soon this year. You know, hopefully before the summer.
Soon TM.
Soon TM. But and then they'll announce the crew, and then from that moment, the crew then have about 18 months is usually standard for training. And so 18 months of training, and then it'll probably up to that 2 years until we're completely ready to go. And they have a team of folks at Johnson Space Center that are responsible for coming up with the training regimen, and they've been doing that for the last couple of the years. So they'll be ready as soon as that crew is selected. They'll start the training program. Yeah.
That's going to
Very
be
cool.
amazing.
Yep. And then Artemis 3 will be announced probably about 18 months to 2 years out as well. So we don't want crew fatigue, so they don't announce a crew until we're about 18 months to 2 years out. Otherwise, you keep training and training and training for
Gotcha.
the same mission. Yeah.
It's like there could be too much training
Yes.
in advance. You said crew fatigue.
Yeah,
Is that
they
what-
have it down to a science. All of the psychologists and
Yeah.
all of the folks that work with the astronauts, after all these years of training for different missions, that 18 months, 2 years is about the perfect amount of time.
Nice.
Yeah. Don't ask me why, I don't know. Yeah.
There's a spreadsheet that shows
I'm
why
sure there's
it's
a
too-
spreadsheet, yeah.
Do you know anything about the type of training that they're going to be doing now when they return to the moon? Is it going to be similar to how it was with Apollo, or are they some new technology? So I would imagine they'd have different training.
Yeah, that's a great question. So just last week, I think it was last week, we had a big teacher conference at Space Center Houston, and we had 3 different women that are responsible for different parts of Artemis 3. And one of them is responsible for training the crew on how to do geology and science on the moon. So do I look this way? Do I look at y'all? All right, I'll look at this way.
You look wherever you want. Like
Okay.
we're low maintenance.
Yeah, so there are a team of geologists. Some of them, I think most of them are retired. A few years ago, there were still some that trained Apollo astronauts that are around, but I think most of them have retired. But they are all geologists and scientists, and they take the crew out into the deserts in Arizona, and they walk them through how to identify different rocks, making observations, figuring out which samples are best to take, and then how to log that. So they go through a whole regimen of training for the geology piece. And then there are folks that train astronauts on the suits. So Axiom was selected to build the new moonwalking suits, and so soon we'll get a sneak peek into what that suit looks like. I haven't seen anything yet. That hasn't been released either.
Nice.
And then they'll go through trainings with Axiom and with NASA on how to perform and use the suits. Then you have a whole group of folks that do contingency situations, so they run simulations. So if this goes wrong and this goes right, what do you do? And so they'll throw the book at them to make sure they can handle any situations that might happen inside of Orion. So you have Orion engineers that are there working with them on the spacecraft. Same thing with suits. What happens if something goes wrong and you fall down and you can't get up? They go through all of the things that could possibly happen, and they train for that.
Once again, it's a cast of thousands. There's so many people involved,
Yes.
specialists in each area.
Yes.
There's not one person that I know everything, and
No.
I'm the
Yeah.
one person that can fix stuff. It's teams of specialists.
It is, and one of the things I think is kind of cool, if there are any teachers that are watching, over the years NASA has learned that they will hire former teachers or teachers that are ready to do something different, and then train them on the systems, and then they teach the crew. So over the years, there was Lucia McCullough, who was on our panel last week. She was a former teacher, and they brought her in to teach astronauts because they found teachers, it's a gift that you have, right? And it was better to teach the teachers on the systems, and then they teach the crew. So you'll find a lot of former educators on the astronaut training team. I love that.
That's
we could be on
interesting.
the
Yeah.
What do you think?
We'll train some astronauts some stuff.
Yeah.
Does that mean we get to try it first?
Yes, it does. I think. Great. I don't make the rules. That's just how NASA does it. There's just people saying thank you so much.
You're welcome.
For sharing all the information and spending time with us. Some people excited about that's what I'm doing. I'm reading the chat while we're doing this. People excited about spacesuits.
Yes.
As well.
I can't wait to see the spacesuits. Everybody loves spacesuits.
Some questions that we can't answer, like who are the astronauts and when is it going to be announced? Don't even bother asking.
I don't know who they are, and I can't share that date. And the date that I know has changed like 3 times anyway.
Yeah,
so
yeah.
okay.
some people that want to visit Intrepid because they've seen the stream here.
Yeah.
But beyond that,
Yeah,
it's just a lot of thank you.
Yeah, you're
So
welcome.
Thank you for being here.
Yeah,
What do you-
follow along on. We've got so many social media accounts,
It's
and there's
true.
really cool YouTube videos to watch. There's so much content out there that we want all of you to be a part of our Artemis generation, and then for those that are much younger, you are also part of the Mars generation too.
There
so
you
you
go.
get a little bit of both.
What's the project y'all have here for the kids? I see them throwing cups in the air.
Yeah, so there's 3 different things that you could do if you were here, and you could do them at home with us if you want. You can create your own astronaut spacesuit.
Nice.
Yes. And this is a lot of fun. I've seen many colorful spacesuits. Unfortunately, our spacesuits will never be that color because we have to think about sunlight and, heat transfer and all those things, but it's very cool designs.
But patches,
and then
crew patches are a thing.
Yeah. Can I borrow your rocket for just a second? Can I show them? Yeah. And so then you can also build your own SLS straw rocket, and these are available online that you can do it at home. Yeah, and so you just fold it and you put a straw inside, and there you go. You launch a rocket.
Nice.
Oh, there we go.
Oh, there's one ready for
Would you
lunch.
like for me to demonstrate?
It's Artemis 2, 1.5.
Woo! And
Hopefully
then
that got where
lastly,
it
we
was
have an
intended
Orion
to go.
parachute system. So Orion splashes
I
down.
recovered it for you.
Thank you. Thank you. Orion splashes down in the Pacific Ocean, and so the students can make a little spacecraft. See, there's me with my purple hair.
Nice.
And then let's see if I can do this with one hand. I have too many things in my hand. And then you parachute. Well, mine didn't work very well, but there you get the idea. Yeah.
And it's already on the Navy ship.
It is. Yeah, and
recovered
we already
straight
have
to
a
the deck
crew
of the
here to
Navy ship.
recover it and bring it in.
Yeah, just like the history of Intrepid, which we're covering capsules.
Yeah.
Perfect.
Yeah,
Perfect.
perfect segue into whatever's next.
Full circle.
Thank you so much,
You're
Patricia.
welcome.
This is
You're
really
welcome.
wonderful.
It's
Thanks
great
for
to
being
see you guys, and hopefully you can come and visit Intrepid, or we've got other NASA visitor centers. So if you're not local to New York, all the NASA centers have some sort of museum or visitor center. Yeah.
Excellent. We'll see you for Artemis 2.
All right. See you for Artemis 2.
All right. So we are getting critically low on the battery, so we need to go back to our crow's nest over here. And I think we can go up there and talk about Kids Week just real quick. What are you doing next? Do you have another thing to say at 3 o'clock?
Thing to say.
A thing. She has a thing to say at 3
things
o'clock.
to say on the hour, every hour. But let's go.
But come back to our raised, our disco deck, I think we're referring it to. It was a straw-assisted takeoff, a single straw to orbit.
Hopefully it
Nice.
achieved where it was trying
I'm
to
going to go back and tell them some of those things. Share it with the Artemis crew. All right, go on. Yes, but we are getting low on the battery that we had. How long did that stream last? I'm going to have to go look it up. I don't even see how long we've been live, but just walking around. Yeah, there's the laptop in the behind the scenes and everything. We don't really have light up here, which is fine. I have the light in my pocket, but I'm not even really worried about the light. I think, did we talk to most of the people we wanted to talk to?
I think so, yeah. We had almost everyone down there today.
Look, see, I'm going to shine the light at us all of a
But
sudden
again,
like
we've
this.
got, all sorts of different things going on all week long. So again, NASA will be here for the next 2 days after today. So if you are local, or again, if you want to hop on a plane randomly, just come on by and visit. That's fine. Come by. Of course, we do have the Space Shuttle Enterprise upstairs on our flight deck.
Love us.
The largest cultural artifact from space, I think, is what they call it in the Northeast. Which is a big deal.
Nice. Okay, it's
I
a big
love
deal.
Enterprise.
It's a big deal.
Tell us in chat what your favorite
just do the
space
heart
shuttle
thing?
was. I did.
The camera's
but the
gonna
answer is
die.
Enterprise. The camera's going to die.
The
The
battery's
camera doesn't
gonna
like
die.
Enterprise. But yeah, come by, visit us. We've got fun stuff going on all week long. And of course, tomorrow at 3 o'clock, we have our Astro Live.
That's
so
true.
it's going to be NASA astronaut Jessica Watkins in conversation with former NASA astronaut Mike Massimino. And they'll be talking about life in space. And she broke a record on the International Space Station.
Yep.
So
We're going to stream that as
We are.
well. So NSF Live tomorrow at 3 o'clock Eastern Time. That's going to be Mike and Jessica talking about life in space. And then after that, the presentation is what, like 45 minutes or something?
Yeah.
How long is something like that? After that, Jessica's going to come up here and sit down with us
And we'll have better
just
lighting.
talk to us.
Yeah.
So that's what's happening tomorrow for NSF
Start
Live.
thinking of your questions if you
Yep.
have any questions for her. But it's going to be a really nice one-on-one.
Yep. So that's the plan for tomorrow. 3 o'clock is when we're going to do the NSF Live, the chat with Jessica and Mike. And then afterwards, Jessica's going to come up here and sort of hang out. We need to get a fan for tomorrow. It's a little warm up here.
It is a little warm up
It's like 30 degrees outside, but the inside of the museum is warmed up.
And there's people.
And we're at the top of the hangar bay.
Yeah.
Yeah. So, anyways, folks, thanks so much for hanging with us. This is, again, an experimental thing. I feel they do make little sticks for these. Like, I feel like sticks would be easier. But
next time.
but hopefully you could hear everything. Put some comments down below and just let me know how this went. I love doing things like this. I love walking around and talking with people, but we don't do it all the time, and so we don't know exactly how it's going to work. Especially we haven't had a chance to do it in a while.
Yeah.
So let me know how it went. Could you hear us okay? Was it too distracting? Was it hard to see things on screen? Thanks to the mods who would put in links, like when we went and talked to somebody.
Oh, great, yeah.
They put a link into chat. So mods, thank you for
Scroll
doing
back
that.
through if you were curious.
Yeah. But I think for now we're going to shut down this little experiment for the day and charge all the batteries up, and we will be back tomorrow at 3 o'clock Eastern.
All right. Thanks for tuning in, everyone.
All right.
Later, nerds.
But
Can I say that? Can I say that?
Yes. Oh my gosh. Everybody says that now. Literally everybody at NSF is like, later, nerds, later, nerds. And
It's
I'm like,
a good catchphrase.
gosh,
Should
I
we
should
say
have
it together?
copyrighted it.
Should we say it together?
No, that's weird.
Okay.
No. 3, 2, 1. No, I'm kidding. Well, to stop the stream, I have to click on the laptop behind me, so don't point it at me or anything like that. Or you could show me clicking on the stream. I don't care. But y'all, we are going to shut it down. Again, Intrepid, thanks so much for having us out here.
Anytime.
Always a good time. And we will see you nerds later.